Right. Okay, I can see that we have people joining in. Thanks everybody for joining us today. We'll be starting the workshop very shortly, but just some quick guidelines before we start the workshop. So just make sure that when you're not speaking, you're muted, just to avoid some background noise. And also just make sure to raise your hand before you're speaking. And Vamshi or Jenna will one by one take your questions. You can also use the chat for questions, and also try to keep your camera on. It will make the workshop more engaging. And don't worry about the recordings and the resources. They will all be shared afterwards, like early next week, most likely. And that's all. So very excited for the workshop. And Vamshi, you can take over. Thank you.
Perfect. Thank you. So, hey, good morning, good afternoon, everyone. Welcome to this workshop. So, myself, I'm Vamshi. So, let's give one more minute before we get started. It's 11:59 a.m. Eastern. So, let's give one more minute for the audience to join.
We'll go over that. You won't need Harsh. We won't actually, we'll be going through like creating your account and getting set up. We'll be running in an Instruct platform or a workshop platform. So you won't need to have anything set up locally other than a browser.
Perfect.
Yeah.
Thank you.
Yep. Yeah. If you're joining us, please say hello in the chat. Maybe share where you are joining us from. I'm based in Minnesota. And I'm Jenna. I'm one of the workshop hosts today with Vamshi. And we're gonna get started real soon.
Yes, yeah. Hey, thanks, Jenna,
Yeah.
for the intro. So, again, I'm based out of Washington, D.C. Nice weather. We feel like an early fall from last 1 week. Hopefully, this will be there for like next few weeks. Mm, okay, so along with us, we also have a few more folks from Pinecone. So we'll give one more minute and we'll start the intro and we will start the workshop. I think it's 2:02. Jenna, shall we get started? Okay. Okay, perfect. So, hey, welcome everyone. Good morning, good afternoon, for the time works based upon your time zone. Um, Myself, I'm Vamshi. So we extend a warm welcome from Pinecone for all the attendees in the workshop. So I'll quickly get started with the intros. So myself, like as I said, like Vamshi Enabotala, I'm a principal architect at Pinecone, like focusing mainly on the partner engineering and solution engineering. So like we help companies accelerate high impact and data and AI initiatives. Myself, a little bit of myself. So I'm a AI technology evangelist and an engineer with over 15 years of experience, like mainly driving innovation, research, and development in the fields of computer vision and generative AI. With me, I have a pleasure to introduce you to Jenna, who will be the co-host for this workshop. And along with, we have two more amazing folks from Pinecone, Arjun and Corey, who will go the intros, who will be, helping us with this workshop. Having said that, Jenna, like.
Hey there, I'm Jenna Pedersen. I'm a staff developer advocate here at Pinecone. I get to work with developers from various walks of life who are learning about vector databases and trying to incorporate them, or various retrieval type of solutions into their products. My background is I've been a full stack developer in various forms for many years, and so yeah, so I am like many of you. Yeah, and like Vamshi said, we've got Arjun and Corey here as well. I don't know if you want to say hello quick.
Hey everybody, my name's Arjun. I'm a developer advocate at Pinecone. I'm here to help Jenna and Vamshi during the workshop, so if you have any questions, feel free to shoot me a message in the chat and we'll help you.
Hey everybody, my name's Corey Waddingham. I'm a partner engineer here at Pinecone, but I also help out quite a lot with the developer advocate team. So like Arjun, I will be standing by in case anybody has any problems or questions, just to help out in the chat.
Perfect. Thanks a lot for the intro. So, Corey is my partner I'm partner in crime in the partner engineering, and Arjun is partner in crime for Jenna in the developer advocates. And we as a team, we wanted to get you understanding about the Pinecone and what are the amazing things that you can build with the Pinecone. So having said that, so I'll keep going. Okay, so this is the agenda for our workshop. It's a 3-hour workshop. Yeah, pretty long workshop, but we wanted to get you a flavor of hands-on build. So as part of this workshop, what we'll do is we'll cover like what is agentic AI at a very high level, then followed by how Pinecone helps build amazing products or amazing use cases. And in this workshop, you will roll your sleeves and you will put your, code development at work. So for that, like what you'll do is you will run or build the use case along with us. So you'll take the pleasure on looking into the code, running the code, and also building this application on your own. So to do this, you don't need to do any, SDKs or any installations. All you need to have, you already have a laptop and internet connectivity. So we'll provide you a link which has all the, softwares installed. We want you to get the real learning experience. Okay, so first, like we will in the next, like I'll kick off with like what is this workshop about? What you'll be learning in this next 3 hours, and how you wanted to, build that application. Number two, Jenna will give you a big picture. So we wanted to show you like what you're, actually building it. So we wanted to give a demo of it. Then followed by a Pinecone intro. So people who doesn't know about Pinecone, we wanted to give you a high level of like what is Pinecone, what do we build, and what we specialize in. And people who knows about Pinecone, we wanted to give you a deep dive about like what is our architecture, like and what are the differentiators from like the other vector therapies out there. Then we'll go into workshop setup. So it's like a simple to setup. So one, we will create a Pinecone account because to get started. And number two, the platform, the platform where you will run this workshop. So we will, again, no tension. So we will walk you through every step of this workshop. Then you will run the workshop on your own. And even that we do at a modular level. So each module, so we will show you how to run it and you'll run it. And if you have any questions, we are here and our moderators are here. So we'll help you with it. And then finally, we'll close this with a call to action. So from here, where you can go, how can you build your own use cases? And while happening that, we can also have a QA. So if you have any questions or anything that you wanted to talk about, you can ask it. But again, we will limit on the questions because we have a pretty tight agenda. But again, we'll be happy to answer any questions. In case if we could not answer your questions today, we will take them and we will get back to you on email. Cool. So, okay. So let's start with like what are we solving today? Like what are we talking about? So everywhere we are hearing about agents are taking over. But let's get on to the root problem. Like what are we trying to solve? So I'll start with a quote. In a world of deluged by irrelevant information, clarity is power. By the way, this is not my quote. So that is from Yuval Noah Harari. So what we talk today, so we are constantly bombarded with vast amount of information. So we have petabytes of information around this world. Now, when we are looking for a certain help, all it requires is certain amount of correct context data, which could provide the clarity. So we are been now seeing the explosion of large language models, which have been trained on this petabytes of data, but even they lack this clarity. So, so in this agentic AI application, we will talk about the clarity. We'll highlight the importance of being able to cut through all this noise and find a clear understanding. Like having this clarity will allow individuals to focus on what truly matters and make the sense of world around them. So that we will look as part of this agentic AI applications. Now, sorry. Okay. So in this agentic AI, right, the success depends on more than not just retrieving the data. So it requires about delivering the right context to enable these agents, because we need to provide the right set of informations for the agents so they can reason, they can plan, and they can act effectively. Now, without this, rich or real-time context, systems become unreliable. They hallucinate. So they try to, pretend they are right, and which leads to like they are prone to errors and also limited to basic like one-off queries. So that's why, having the right set of information to the agents is very important. That is why it's a context engineering. So this is the discipline of managing information flow to an agent, like how you retrieve the right set of data, how do you provide to the agent, and how do you take further actions. Now, this is now more important and critical than prompt engineering, so that you can build a trustworthy, scalable AI applications. Okay, so again, we spoke about a high level of the problem. Now we'll talk about a quick teaser of the solution. So like Pinecone provides the foundation for this context engineering. So it does by providing like enabling fast and accurate semantic search, getting the right context of information for that query or for the task, and also it can re-rank across large data sets because there are much more information. So we wanted to rank the data which is more relevant to a given task. So by supplying this to the agents, the most relevant high quality context, now Pinecone ensures they can make a better decisions, handle complex tasks, and also deliver reliable outcomes at scale. So now what you'll learn in this workshop. So you'll learn about like how the context engineering will accelerate the discovery and enables the reliable agentic AI. And for having this right context, now Pinecone will provide the relevant context to agent in making a right decisions. Now, in this workshop, you'll also see a real world examples. So like in this workshop, we'll be using a financial documents like 10K documents, which is like a complex document, which has been submitted to SEC for about the, financial transactions for that year or financial stats for that year. So now we will be taking that data and we'll be, parsing through that and making sure we are getting the right context for the agents. So in the same thing, we'll also show you like how the re-rank helps. Like you have retrieved the information, but putting that in a right set of order is very much important. So we will see about like how the re-ranker will help to improve the relevancy and accuracy of that, data to that given question. And the main thing, you will have a hands-on of this, the entire thing in action. So you will have the code, you will have the luxury of running the code. And if you wanted, you can go ahead, and modify the code and try it. So this is the time to being hands-on. So we are turning the ambiguity of like different disparities of data into a right set of information, which is more relevant, more useful, and intelligent, and making the systems intelligent. Sorry. So having said that, I'll pass it on to to Jenna to speak about agentic AI.
Yeah.
Sorry.
So we've heard this term now. It's part of the title of this workshop, Agentic AI. And I just want to kind of give a little overview of what it actually means so that we're kind of level set on what we're talking about today. So unlike conventional AI that simply responds to prompts, agentic AI systems are going to be able to autonomously plan, reason, and take actions to achieve goals. And so their behavior is goal oriented. They have specific tasks that they're tasked with, and they break those tasks down into to smaller pieces, and they work towards a solution. They integrate tools as part of this. So these systems they interact with external tools like APIs, databases, other services. And this is to gather information and to potentially perform actions out in the real world. Um, and actually, Vamshi, you can go to the next slide if you'd like, if you
Yep.
can. I'm kind of just describing this in like high level, so I'm not going through specific pieces of it. Um, so there's also it also incorporates multi-step reasoning so that rather than just providing like one chat prompt and one response output, there's potential for going back and forth. And engaging in kind of these extended reasoning chains, iterating back and forth and refining the retrieved data that gives us even better results throughout the process. And then finally, just context awareness. These systems, they are maintaining context across these interactions. And so like, as you can see here, we've got the persistent knowledge down at the bottom of our diagram, but you also might have something like short-term memory that maintains that conversation over time as well, and other context over time as well. So what this lets us do is it lets us take maybe what might have been a static chatbot in the past and turn that into something that can solve a problem for us. This could be research, analysis, recommendations, and then potentially even execute tasks. Um, we're not going to do the task execution today. We're actually just implementing a couple of retrieval tools today, and you'll see that as we do that. But what this allows us to do is we can combine our retrieval augmented generation and our vector databases like Pinecone with for retrieval, and then these systems are now grounded in authoritative and relevant data. So imagine if your agent is trying to make the model behind it is trying to make decisions off of inaccurate data, then potentially the wrong decisions are being made over time. You can go to the next slide.
Sure.
So we've talked a little bit about this so far. So in this workshop, we're going to be building this agentic AI system. I'm actually going to share my screen now.
Yeah, I'll stop sharing.
Share.
Go ahead, Jenna.
You. Someone might have to accept it. There we go. Okay, so in the workshop, we're going to be building this system that helps us gather insights about these financial documents that Vamshi mentioned earlier. We have 10K documents, and let me actually see if I can pull them up really quickly. I didn't have that ready. One second. I'm going to get that quick.
While Jenna is sharing that, so I wanted to share a few things. So the reason we have taken the 10K documents is we wanted to give a flavor, because when you're looking at 10K, it is partially, structured and unstructured because you have tables, you have text data. So we wanted to, parse the data and empower the agents with this unstructured data. So what we'll do is in the workshop, we will take a company called Compact, and we will take around like 8 to 10Ks, and we will load them, and we will build an agentic AI application for semantic search.
Yep. So this is one of the documents that will
Are you
be
sharing the screen, Jenna?
I think I am. Did it not? Did it unshare? Maybe it
Yeah,
unshared.
now we can see that.
Okay. Okay, so this is one of the documents. This is just from 1994. And as you can see, there is a number of there's formatting and markup and text, and there's some tables in here. But we don't need all this information. We just need the bulk of the data, not the formatting and the markup. And so What we're going to be doing as part of this workshop is going through pre-processing this data so that we can clean it up and embed the information that is the most meaningful to us. So what I'm going to show you here in just a second is, one second, sorry. Uh, okay. This is ultimately the goal, our end goal, which is that we're going to be building this back end portion of this web app. So what I want to show to you right now is the front end portion of it, so you can see how we interact with it, and the types of questions that you can ask. So the data has already been loaded into our Pinecone index. We've already implemented this, so I'm just kind of showing you the interactions that you can do. So here we've got a handful of questions that you can ask of the tool. And I'm missing a piece, which, one second. I'm not gonna, I'm gonna have to set something up and it's gonna take me a minute. So, what I want to share though is that through this user interface, you will be able to, you can select from the questions here that we've suggested, or you can type in your own question. So I could ask information about, financial data about the Compaq company. I could potentially ask information that's not about financial information. So, as you can see here, we've got some examples that are about the founder and what this person did before and after they joined Compaq, or they worked there. And in that case, if it's not about that financial data that's in our Pinecone index, that are in those documents that we embedded and it loaded into Pinecone, then it's going to actually use a different tool. It's going to reach out. In this case, we've got a web search tool where it will reach out there, get the information, take those web search results, and then send that to our model for text generation. I think that
Jenna,
that is,
so
yeah,
we can do one thing. So
yeah,
what I can do is I can talk about Pinecone. By then, if you can, I mean,
yeah,
this one we can come
sure,
back to this one. So that way,
perfect.
you'll have some time. So,
Yep,
okay, let
let's
me
do that.
share my screen.
Yeah, I just had a question before you share your screen.
Yeah.
So looking at the current screen that we have, these example questions, were they auto-generated or those were coded in the front end?
These are hard coded in the front end as
Okay.
questions that you can choose from. We just wanted to give you something to start with. But you can actually type, you'll be able to type your question in down here, like if you have other questions.
Okay.
Okay, just providing a little bit of flavor. So in this application, what we did is like we had two tools, because tools are the one which provides data to the agents to make, to reason, to plan, or make decisions. So to show you that flavor, so what we did is like we had one tool which, I mean, all these 10K documents. So we have loaded into a vector database, Pinecone vector database, now which will act as a knowledge layer. At the same time, we had a web search tool which will go to the web and get the information. So, and like you can extend the solution to n number of data sources, like adding a respective tool. Now, so whatever like questions Jenna is showing, just for a, I mean, example. So you can ask any questions. So it will try to, based upon the question, it will try to see which data tool it should get in, whether it should go get it from the vector database or go get it from the web search or get it from both. So that way, I mean, we can, I mean, get information and plan the next actions based upon the tasks.
So when you're talking about tools, are you using that synonymously with agents, or it's something different?
No, it's like synonymously with the agents itself. So the tools.
Okay.
Yeah. Perfect. So let me share my screen. Jenna, can you unshare your screen once?
Yeah, that's what I've been trying to stop doing.
Yeah.
There we go.
Thank you.
So can we say this is like an agentic RAG application?
Yes. So it's an agentic RAG AI application. Yes.
Okay.
Again, it's I would say like this is a fundamental start because like how you are envisioning agents and how you are to build, and you can extend to like a number of things. Like you can add more tools, like getting the data from different databases, like say structured databases, or even any other graph databases. Or you can add more kind of evaluation tools like, hey, I got this. Like, how do I process this, and how do I make sure I have the right set of information? And also you can add, some tasks to it. Let's say if if I had to take an action, how can I do that? So this is just a starting point. Okay, cool. So what I'll do is in this next 10 minutes, what I'll do is a quick high level overview of Pinecone and how you can, build a use cases with the Pinecone. Okay, so, okay. So again, before introducing Pinecone, I'll say like what are the key challenges that we are solving, and why we are here, like helping to serve the purpose here. So like one of the key challenges with the large language models today is that they're trained on a static set of data and they have a fixed cutoff. That means they don't have the latest information, or they don't have a clarity of the data or the task that they wanted. So they need a latest information or a fine-grained details about what they are working on, either it answering a question or looking at a task. So if it doesn't have that, what they do, they hallucinate. So they pretend to be like right. So that's why you see, the large language models are not reliable or relevant. So Pinecone solves this by acting as a long-term memory for your AI applications. Now, we are a purpose-built enterprise-grade vector database that stores and retrieves like vector embeddings. So in a bit, I'll get into like what is vector embeddings. So that is how we represent different modalities of data. So we have text, we have images, and we have videos flowing around. So those are all comes under, unstructured data. So to get the insights of this data, so what we do is we convert this raw format of data into vector embeddings and store it. So that will be used for retrieval. So Pinecone is a fully managed a serverless database. So which means you don't need to worry about either infrastructure like or scaling or sharding. It just works. You can sign up and you can start small and scale until billions of vectors. So Pinecone is optimized for a low latency and high accuracy search over billions of vectors, and it's built to power real world applications at a production level grade. One other thing, so we are a multi-cloud, Apple SaaS application. So we are available on all the three clouds like AWS, GCP, and Azure. And like we are one of the top subscribed, SaaS application in AWS Marketplace. So in terms of capabilities, so along with vector search, we also support, sparse search, like which is a keyword search, and also we recently introduced, a multimodal, in the assistant, which is a, out of the box solution for all the data retrieval, or you can convert your images and videos into vector embeddings, and then you can load it into vector database for your seamless semantic search. Um, Again, so we will talk about security in the next slides. So today we have been trusted by over like 5,000 companies and with around like 600,000 developers adopting to our, tool, application, and with around like millions of SDK downloads per month. So the momentum is real. So at its core, like Pinecone is what makes your AI knowledgeable, context aware, and production ready. Okay, so now let's look into so we spoke about vector database and we spoke about semantic search. Now let's look into like what are the use cases or the problems that we are trying to solve. So at a high level, Pinecone enables you to build AO solutions that's not only intelligent, but also like they are aware of the context and mainly the reliability. So you can trust the data from the source, like where it is coming from. So let me walk you through like common use cases. So obvious, like, so it's a RAG, retrieval augmented generation. This is one of the most popular right now. So a lot of organizations, they uh, they look at Pinecone to derive insights from the unstructured data. Either it could be internal, like proprietary data, or it could be, I mean, a huge corpus of unstructured data. So Pinecone powers this by giving the models, like the large language models, access to the right and the relevant context at the query time. So it acts like a long-term memory where during the query response, so the large language models will get the right context from the Pinecone database. So whenever like there is a question for the RAG application, so the model, now this time the model doesn't get. So instead it will retrieve the right information from the Pinecone and responds with confidence. Next one is semantic search, and extension of that would be a multimodal search, like searching from different modalities of data. So now we are seeing a big shift from like a traditional keyword search to semantic search. Like traditional keyword search goes and just find out that word. It doesn't understand the meaning or a human intention behind it. But on the other hand, the latest advancements in the search, which is semantic search, it will understand the intent and the meaning behind the query. So now Pinecone excels here by letting you search across different vector representations of the data, finding out what's relevant, not just by matching the keywords, but understanding the meaning. Let's say if I'm searching for a dog playing in the snow, so it doesn't look for like dog word match or a snow word match. Instead, it will look for like the actual human intentions, like where it's supposed to be a dog playing in a environment of like snow, like that. And a extension for that, like as I said, multimodal search, where you're searching not just across text, but also like from the different modalities of data, like say from different pictures, audios, and videos combined together. So with Pinecone's high speed and low latency vector search, now you can build systems, for example, that could retrieve product images, analyze video segments, and even combine search across multiple modalities. Third one is agentic. So this is where the AI agents are starting to take actions based upon the goals. So in these use cases, Pinecone helps agents maintain the context across all the steps, recall information, and interact more intelligently across a sequence of steps. Like fourth one is recommendation systems. Like think like personalized, video feeds, like product suggestions or news recommendations. Now behind the scenes, everything is represented as a vector, and everything is a finding out the similar items for a given items. So Pinecone helps match users to most relevant content using the similarity search. And last one we would say is data classification. In classic ML problems like document or image classification, now Pinecone is used to quickly retrieve the similar items from large data sets and enable accurate and near real-time classification using vector proximity. Cool. So these are a small set, but highly focused use cases. But Pinecone could be used for anywhere where you're looking to find out similar items or semantic search, where you can across the different data sets. So it supports different types of data, text, image, and audio and video. Okay. And we recently also, introduced like inference, like where you can, have a model, you can choose a model to generate vector embeddings. And you can seamlessly integrate into your favorite tools, like either it could be in AWS services or like other cloud providers or even the external services. So we have been integrated with the different applications. And finally, so we also have a re-ranking API where you can re-rank the set of searches based upon the given query. And extending that one, so Pinecone supports metadata filters and namespaces where you can confine the results for a given query. Customer success stories. Again, like there are like many customers like who are like now successful with their production grade applications. But I wanted to talk about one given the time, like we have only a few minutes left. So I would like to highlight one of our most inspiring customer stories, like which is Frontier Medicines. So Frontier Medicines, they are a cutting edge precision medicine company. Like they are working to transform how we treat the genetically defined diseases. So like what makes their work especially powerful is that they're targeting disease causing proteins that are previously considered undruggable, because previously they're working at high level, so it's not a DNA or specific gene level, but it was like overall capabilities. But right now with these advancements, they're really considering like how we can we develop medicine which will act on a specific gene type. And this is really hard like scientifically, because getting through this many number of DNA genes and everything is very tough, and it's like computational challenge. To do that, they rely heavily on large scale semantic search. Like we are talking about comparing hundreds of millions to billions of molecules, all represented in the high dimensional vectors. Now, to find the right drug for a candidate with its desired biological properties. So this is where like Pinecone helped or played a crucial role. So by deploying their application in Pinecone serverless vector database, they run massive vector searches in production. So it's at a billion scale, like tens and 20 plus billion scales of molecular information, which is represented as vector embedding. And when searching across the list, they wanted to have a low latency and high accuracy search results. And perhaps like most important, we wanted to be cost effective. So that's where Pinecone helps in being cost effective while providing the critical performance, like getting the low latencies and also highly accurate solutions. Okay, what makes Pinecone different? Like what are its differentiators? First one, we'll start with the developer ecosystem, like ease of use from zero to production in minutes, literally in minutes. So in within 10 minutes, you can get started. So just simple 3 steps. So you can either go to the Pinecone website, subscribe there, or if you are building your application on a cloud, so you can go to the marketplace and you can subscribe for the, our application. Then you create an index and API key, which in this workshop, I'll show you how we can go create an account in Pinecone, create an index and create an API key. Then third step, like download the SDK of your preference programming language and you can start querying, loading the data and querying the data. So there is no infrastructure setup, there is no cluster management setup, and you don't need to do the complex capacity planning, like how much nodes, how many resources that I need. You don't need to do anything. You can start with 1 or 2 vectors and you can scale all the way until billions without even reprovisioning. So it's just clean APIs and powerful performance. So this is a huge win for teams like who wanted to move fast, getting through bogged down instead of like DevOps things, all those things. So if you have an idea or if you wanted to work, get started. It's simple, like get started in minutes. Next one, vector search at scale. So Pinecone is like fully managed and serverless, like, which means as I said, like need to never worry about my capacity planning or provision resources.
Sorry
This
to
is
cut you off. Is there is no open source, so I cannot bring my own cloud. Is it still Pinecone managed private region?
can you come back on that question, Giri? Like open source.
Open source as self-host. There is no true open source and self-hosted by Pinecone, right?
So you're talking about open source solutions similar to Pinecone?
Yeah, the Pinecone won't allow like any open source or a free to self-host.
Um, I'm not sure because
It's
again,
not an open source tool. We do have I think you're going to talk about this in a minute, but we do have something called Bring Your Own Cloud so that
yes.
you could provision it within your own environment.
Okay.
Again, so you can't deploy the entire application in your cloud, but what we did is like so to get you the data sovereignty, so you can host your, the data part of it, data plane in your cloud. So right now we have a limited support towards AWS because it's a new feature we're working on, but in future we'll extend it to like other clouds.
Okay. It's not fully managed. We cannot do that. It's not freehand for that. We can leverage it, right?
I would like to understand more in terms like what you are trying to manage, like in terms
So
of
it's
the
a free
application
resource,
itself.
right? Companies, for example, we like to open source something we like to test it in. For example, MongoDB, right? They give it community edition. The we tested it. We use that in open source. I mean, then they say enterprise edition, and also they can provision. We can host as a enterprise edition as a self host. We can bring our own cloud. Anything we can install. Is that still possible in Pinecone?
Not to that extent, but one thing I could say, like if you want to test it, we have a local edition where you can test it in your laptop or anywhere, and so you can try it there.
That's one of the cons, right? Pinecone. Still, it is, you know, yeah, it's progressing. That's what you're saying, right?
Yes, Gary. So
Okay.
again, yeah, this is not an open source solution, but again, like we would like to again after this workshop, we would like to get in touch with you and see like
Okay.
what is the use case and how the best we can, implement that one.
It's not also it's not also OLTP. Might be relational DB. It's only a vector DB. That's it.
It's only a vector database. That's correct.
Got it.
Yeah.
Thank you.
Okay. Perfect. Thank you. So in terms of scale, how is this possible? Because we have decoupled our read and write architecture, so which will independently scale based upon whether ingestion or query capacity. So that will help us to scale up or scale down the resources based upon your usage. So, and we use in-memory caching, which will help us for the fast access and for the more frequently used data. And also we use blob storage for long-term scalability. So this all sets up for getting the right set of data in terms of freshness. And that means like when we talk about freshness, right? So you can query the data right after it's been inserted, almost instantly. So these are the features which help us to scale to billions of vectors without even reprovisioning. So that's like one of the, cutting edge thing that we will have with the serverless architecture. Next one, I'll be a little faster because like in this time. So cost effective scale. Um, so let's start with the right path because like we have implemented again, the reason I wanted to start with the right path is like how it's cost effective and what is bringing this cost down. So we have implemented like adaptive indexing architecture, which is built on like log structured merge trees. So this will allow us to efficiently handle both small and dynamic workloads. So based upon your workload, we under the hoods like manage your data in terms of like slabs, like what are the algorithms to use. So that way you'll get the top, accuracy and performance. So that will help us also to get a large high throughput vector sets. So in terms of like the query throughputs. So for small slabs, like things like a small vector sets, we use like lightweight techniques like scalar quantization or random projections. While for the high slabs, we have like compacted with the uh, quantization techniques. So this gives us to help serve different kinds of workloads. Now, in terms of cost, we are usage-based pricing, absolute usage-based pricing. So you will be charged for like how much of the actual storage that you're using and what are the read units. So because since the architecture is decoupled, you have a write path, you have a read path. So you'll be billed for only the units that actually been consumed and read units and write units. So compared to other things, right, like other technologies, like where uh, you need to do a complex capacity planning, you need to provision the nodes and start working on it. Whether you're using it or not, you will be paying for that resources. In Pinecone, so you'll be paying for absolute usage. So that helps us and also helps you to be very cost effective and that way at scale. Multi-tenancy. So another area where we lead is multi-tenancy. So with Pinecone namespaces, so which is like the namespaces provides you an isolation of each tenant data within a single index. You can think like it's a logical separation that is secure and cost effective. So each namespace scales independently based upon the workload of it. And that way it helps you, keep the cost optimized and also low latency. And in terms of cost, it will be charged at overall index level. So you can, be flexible with your namespaces. So that will provide the security and access permissions along with being cost effective. Finally,
I have a question related to that. If we go back, normally from a customer perspective, I get it, but normally you have customers that have interdepartments or complex customers that have multiple entities, and they do have a aspect of having shared data. like data that is used between entities. In this model, would we replicate them in both instances? How
No,
would we manage that?
yeah, access management could be done in multiple levels. So at a high level, you can do at a project level. So where certain departments can use that project, and in the next you can do at index level. So the data storing, and next is namespace level. So within an index, you can have different namespaces. And
Okay.
at last, we also have RBAC, like role-based access control. So to your question, like say if multiple teams wanted to use the same namespace, yes, they can do. So you can set up the role-based access control. So based upon their access, they are allowed to do it. And even going up a level further, you can also do this with metadata filtering. So metadata is the key value pair where you can, for example, you can give like who in the team could access that data. So that you can apply while filtering. So that will give a more fine-grained access control, but at a cost of like computational complexity. So based upon your use case and how you wanted to, restrict your access control, you can employ like the technique that is more suitable to you.
Okay, I can take it offline. I'm just curious in terms of how much version of data I need to keep. Looks like I can go with a single data set, but I have multiple options in the way how I control access to it essentially. So that's what I understood. Okay, got it.
That you can do it, and even in terms of versions, so you can use a version like again we can take that offline because that
Yes,
itself is a big topic.
it's a detailed topic. Yeah, but
Yeah,
go
so
ahead. Go
we
ahead.
have ID prefixes. So using the ID prefixes, you can maintain the versions of it, and you can point it to which version you wanted. Yes, so we will take it as a
Yep.
further call.
Thank you.
Thanks for that. So I want to talk about security. So at Pinecone, data security and control are core to the platform because especially we support customers in regulated industries like healthcare, finance, and public sector. So let me walk you through, the what are the Pinecone enterprise grade security standpoint. So all data is encrypted, both at rest and in transit, and using strong encryption standards. So we offer private endpoints. So where which will allow your, isolate network traffic. Okay, so which will allow you to isolate network traffic with your own VPCs and completely avoiding the public internet. So your data will be traveling through only through that private channel. And access control is handled through single sign-on, API key management, which in a bit will show you like how you can create an API key and use to access your index, and the role-based access control. So now we can enforce like granular permissions. And for added control, we also support customer managed encryption key. That means like you can bring your own encryption keys, encrypt your data. So except who has access to that encryption key, nobody could access the data. And everything is fully auditable. So we maintain a detailed audit logs for your governance and compliance. One other thing I wanted to mention is BYOC. We just discussed briefly about BYOC, but again, in terms like where you require a complete data sovereignty, or you wanted to have follow the regulations like where your data could not cross your VPC in your clouds. So that's where we have a feature called BYOC, bring your own cloud. So what it does is, so you have a control plane and a data plane in the application. So the entire data plane could be deployed in your own, cloud. So for example, like we have, support started with AWS, and the other two clouds are, coming next. But with this, what you can do is you can enjoy all the benefits of Pinecone in terms of manageability, in terms of features and everything, and also at the same time have your data in your own cloud. So that way you have full control of your data. Okay. Okay. So let us again the main. If you have any questions, feel free to ask in the chat. So our team would help. But if you wanted to discuss further, yes, we'll be happy to have a call with you and talk about your specific requirements. So having said that, now before jumping on to workshop setup, what I'll do is Jenna, would you like to give? Okay, perfect. Then
Yeah, I'll just kind of show what we're going to be building that I was getting set up again.
so let's do two things. So
Yeah,
now like rest is like we will set up the workshop and then like we will proceed on running the workshop. Before that, let's see what you are building that workshop. So we
yep,
wanted to give you a flavor of that. So
yep. So can you see my screen?
I stopped. Not yet.
I can see.
You can? Okay, great.
Oh,
So this is what we're building. This is right now it's just a simple chat interface because that's an easy way to kind of demonstrate what we're trying to do. But behind this is the RAG agent that is invoking the tools. It's deciding when to invoke each tool based on the query that is input, a system prompt that we have added as well, and based on the data that it gets back from any of the retrieval results. So as I mentioned earlier, we've got some sample queries here that we can try. Um, I'll just do this first one. Which company did Rod Canyon co-found? And we can see that it comes back with based on the search results, the company that Rod Canyon co-founded is Compaq. And we can see that the different steps that it's going through to actually determine this answer and then generate the output. So the first thing that happens is it's sending it to a model through Amazon Bedrock. So in this case, it sent it to we're using Claude Haiku for this. It sends the text query, which company did Rod Canyon co-found? And then it comes back and it says, we actually need to use a tool here. We're going to use the web search tool and we're going to execute this query. We look at the next tool, this web search tool. This is the next step that it executes. So it takes that same query, uses the web search tool, and it comes back with some information, some search results here. And then our final conversation that gets sent to Bedrock are the actual results itself. And then the model takes those results and decides how to generate the output based on those more accurate results, that authoritative data. And that's where we end up with this output. If we wanted to, some of these queries, sample queries in here will execute both tools, a web search tool and a Pinecone tool. This one here does that. Which company did Rod Canyon co-found and what is the 2000 revenue of that company? This should invoke the web search tool in order to figure out which company. And then it will use the Pinecone vector search tool to actually search that data that we talked about earlier.
Is that an intelligence of the LLM itself to decide
Yep.
what resources it needs to go after in terms of, I mean, source of data it needs to go after? Okay.
Yeah, exactly. So it's relying on the model to do that decision making. So we'll see this in just a little bit, but in our tool, in our tools that we've defined, we actually say, what does this tool do? What can it do? How do you use it? And we send that information to the model, and the model decides, oh, someone's asking about this. We need to use this tool, and this is the query that we have to prepare in order to get information back from the tool in the right way. So we'll see that a little bit in more detail in the code.
Thank you.
Yep.
Thank you.
Okay, I think this is a good time to switch over to actually getting the workshop set up. Do you want to take that over, Vamshi?
Yes. Let me share my screen.
Yep.
Jenna, let me know when you can see my screen.
I can, yes.
Okay. So, audience, so let's start the workshop. So to start the workshop, you need two things. One, you need to create a Pinecone account. So if you have your Pinecone account, absolutely fine. So if you have an API key, you can use that. In case if you don't have a Pinecone account, now I'll walk through the steps like how can you create a starter Pinecone account. So this is a free account. So it has, you can again, build your applications, but it has few limits like certain data limits and query limits, but which is well sufficient for our workshop now. Next, we'll also do an Instruct setup. So Instruct is a platform now where you will be running this workshop. So I'll provide you a link so you can log into the link, leave your details like your name, your email. And once you provide your details, you can log into the workshop setup, workshop itself. So having said that, I mean, you can follow along with me. First, we will do is like Pinecone account setup. Okay, so you can go to web browser, click, type on pinecone.io, which redirects to our web page. So I'll go slowly, like
I'll also drop some of these in chat as well.
yes.
So yeah, the first one is how to get logged in, or will get you logged in or create an account.
Yes. Again, as it's like, I'll go slowly. So if you have any questions or concerns, let us know. We are happy to help you. So once you go to the main page of pinecone.io, so you see a login button there on the right hand top corner, which is next to the sign up. So we need to click on sign up for the new users, login for the existing users. So let's say go through the sign up process. So click on the sign up. Okay. So here I'm creating with my email. So you can create with your email. So give your email ID here in this space where we are showing it and click on continue. Okay. So this will send you a code to your email. So you can go grab the code quickly and come back here. So I will wait a minute or so here. So that way you're all comfortable. So I'll just repeat, go to pinecone.io, click on the sign up button on the right hand top corner, and that will lead you provide your email. So once you provide an email, so a code will be generated to your email. So it's a verification code. Once you copy the verification code, have it here and click on continue. Okay. So it will start with a few little set of questionnaire. So what you're trying to build. So in this case, again, you can choose anything. It doesn't matter like what it is, but end of the day, we are trying to, see like what you wanted to build, but all the responses will lead to the same console. So I'm building a small or personal project. So start for free. So you'll see an option called start for free. Click on start for free. Giving
Hey,
you details.
Vamsi?
Yes.
Hey, can you share your screen? We are seeing you, then your browser screen.
No, I can see screen. Harsh.
Yeah, I can see it
Yeah, I
too.
can
Yeah, all
see.
you can see is screen. Maybe you
I
need to
can
double
see.
click that other icon, then you get it.
Yeah.
Harsha, you should see the screen where I'm in like create your account screen.
Got it. Thanks.
Okay, perfect. So fill in your details. Business, company, giving my own company name, preferred coding language. So select your language, I think Python, continue. In customize your setup, use case, let me fill in agents. What does your data look like? I have raw documents. And what is your goal? Build an AI feature product. Again, this is just for the data collection. So nothing will change based upon your answers. It will lead to all the same console. Get started. Okay. So account is created. I think it's less than 2 minutes. So Pinecone account has been created with a starter account. So by default, an API key is generated. So API key is very much important. It's the access provider key to access your data. So you can copy this, or even you can create an API keys further. So what I do is like I'll copy this API key and store somewhere reliable. So let me store it here. Yeah, so this API key is required for us to run the workshop. Again, you can grab this API key or you can create a new API key, but make sure you provide a valid API key in your workshop. Okay, so I'm closing this.
And
So
you'll wanna, I'm not sure if you mentioned this, but you wanna make sure you save off this API key, because we'll need it through multiple steps throughout this workshop.
Yes.
And you won't be able to get it back. You can get a new one, but you won't be able to get the same one back.
Yes. Okay, so we are now officially inside the Pinecone console. So this is cancel. Okay. So you'll see this welcome screen, like welcome to your project. So where you can create an index or load from your asset. On the left-hand side, you see the offerings from Pinecone. So at a very base level, you have database in which you can create indexes and also backups for that indexes. So the next one is assistant. So again, I'll quickly go through it because right now we are talking mainly about vector database, but I wanted to show this. So assistant is a rack, a self-managed or sorry, let me put it this way. It's a fully managed RAG application. So instead of creating embeddings and everything, you can directly upload your documents and you can have your RAG chatbot ready within few minutes. And the third one is inference. So inference is the one which you can use to convert the raw text into vector embeddings. So you can use any of these models to create embeddings. So we have few models for, dense vectors and also the sparse vectors. And the next section is API keys. So this is where your access control. So this is the default API key. It got generated now, like once I logged into the account, but you can create an additional API key. Let's say just say workshop, AI workshop, and create a key. So either you can use this key or the first key for the workshop, but you need this API key to run the workshop, which will run next. I'll also copy this one and have it somewhere. And API keys could be deleted if you want. Okay, and finally, I would like to show the manage space, like where you can manage your project and also the access permissions, like customer managed encryption key and access. And the one I wanted to show with like the starter usage. It will also show you how much of the usage you're using. So in a starter, you can use until 2 gig of storage and 1 million read units and 2 million write units. So this is like most important for you to in terms of looking what's my cost looks like and what's my usage. So I'll go back to database, create an index. So there are two ways. Now you can create an index from the console or from the SDK. So we can create a console here. I'll create a test console, test index. So just for you to show how to create an index, but in the workshop, in the notebooks, you can programmatically create another index. I'll just create an index here. You don't need to create this index. I'm just showing to help you like how can you create an index. So give index a name. So you can choose configuration, which embedding model you want, or you can give a custom settings and say which type of vector and what are the dimensions. And metric, so I'm choosing cosine metric. And in capacity mode, I'm using serverless, but also we have an option where you can have your dedicated nodes, which is reserved for like next topic. So in the cloud provider, you can choose your cloud, and region, you can select your region. But for starter accounts, it's only US East 1. You can select that and create an index. Yes, so index is created. Within minutes, you can create an account, you can create your index and start loading the data. So I'll pause here. So this completes our Pinecone account creation. You don't need to create this test index. So you will create the index during the workshop. Sorry, somebody had a question.
Yeah, so why is it mandatory to create a user-specific index rather than the system having its own index? What does it facilitate? Like,
So
why do I need to?
Again, so in your account, index is the place where you store and retrieve the data. So in the
Okay.
workshop, what we'll do is now, as Jenna showed you, so we will take the 10K documents, we will create as a vector index and store it in Pinecone. So where do we store? You will store in your own accounts and index, which you can see.
So, is index in vector database is something similar to schema in relational databases?
Think of the index as the database.
Yes.
This challenged me as well, but think of it as the place where your data is stored.
Okay. Index is not really a similar index in relational databases.
No.
No.
So yeah. Yeah, it's tough. So you can think index like a high level data storage in Pinecone. So you
Yeah.
can, so all the API keys, everything like are associated with this index, and you can store the data. And these are the namespaces which I said, where you can create logical isolation of the data.
Okay. Behind the scene, physically on the server, it is like, is it creating a files, something like data files?
So when we create index, right, it's about the metadata, because end of the day, if you go back to the presentation, there are three things made: storage, read units and write units. So for your specific account, when you create an index, it will create a metadata for you. Now, when you store the data, that will store the data in the underlying blob storage, and it will assign that metadata to your account. So that way you have your own provision of data storage. And when you query it, it will assign read units to go fetch the data and give you the output. And when you write the new data, it will assign write resources to write the data into your index.
Okay. Okay. Very good.
Okay. So now, if no further issues or
So the
concerns,
metadata defines the dimensions as well? Vector?
no. So dimensions are at index level. So whatever you see, so let's say if you have created a 1024 dimensions index, now for its life, the index will be only for 1024 dimensions. So you can think more like a schema here. Metadata is like at record level. For each record, you can add a key value pair where you can do a kind of further processing like filtering or anything, which again, in the workshop, we'll show you like what is metadata and how you can add the data and how do you query using a metadata.
One quick question. So can I change the capacity mode from on demand to serverless once I create this index, or?
So on demand is serverless, basically.
Okay.
So there
Got
is
it.
another mode called provision readment. So provision is like more kind of a definite set of capacity allocated to you.
Thank you.
Okay. So now
Should we share the invite link to the workshop platform so
yes,
people can start going in
that's
there?
my next
Okay.
step. So again, if you have any questions, concerns regarding the Pinecone setup, please
Yeah, I have a
feel free to
question.
drop your question in the chat. Our team will help. Uh, Due to the interest of time, I'll move to the next setup, which is instruct.
Oh, excuse me. For me, the create index button is not activated. What I have to do? Maybe I missed it to watch you.
Like here.
Oh, I,
Can you click on the databases on the left side and click on
oh,
indexes? Let me know what
oh,
you're seeing.
yeah, I used that one. And from there, I used the create index button.
You have to put it in name. I think that's the reason at the top.
Yep.
You have to put in a name and then the button activates.
Oh,
I
okay.
gave that everything. I
Oh, here,
selected.
right? Okay.
Yeah. Yes.
Here. So yes, you need to type in a name here because you need to name your index.
So what is the vector type dense and sparse? What is the difference
Oh,
between?
okay.
So dense is a semantic vector. So you are converting a raw text into a multi-dimensional numerical representation of integers. Sparse is more like a keyword search.
Got it.
Yeah. Okay. So again, I repeat, creating index in here is not mandatory because we'll be creating the index from in the workshop in the notebook. All you need to do is create an account, create an API key, and grab your API key, save it somewhere else. Okay. So, okay. Now, next, let's go to instruct. So I'll provide you a link to you all. So
I dropped a link in chat, everyone. So you can use that. You click to get logged in.
okay. So
Fill out
I'll
your name
go
and email.
along with
Yep.
the audience. So I'll grab. So Jenna has shared a link. So it's called, it starts with play.instruct.com. copy that link, come into this web browser. So let me do it from this console. Okay. And click on that. So you should see this web page. So once you grab on the link which Jenna shared, it starts with play.instruct.com. And run it in a web browser. You'll see this page. So give your name.
Is that going to some cloud?
Again, Instruct is a tool which is built on top of a cloud. Yes.
Okay. Just trying to see if it is going to
AWS.
AWS.
How does it connect to our environment?
So that's the API key. So when you give your Pinecone API key, so that whatever we think Instruct is like a virtual machine where you're running your workshop. So from the workshop, when you plug in the API key, so that will connect to the Pinecone your account.
Got it.
I created and started that agentic workshop.
Yeah. Good. Give me 1 second. I'll be there. Okay. So fill in the form, submit the details. So this will give you an access to the workshop. So you'll see the workshop title and what we're learning it and the actual link to the workshop. Okay, sorry. So you can get started. So this workshop has 7 different modules. So in that modules, let me start this and show it to you. But I would like to pause it here for a few minutes and see if anybody has questions or concerns getting into Instruct.
So we'll just click on the start and stay there, right?
Yes, click on the start and stay there. Now, in Instruct, we have different modules. So each module is a challenge. So we have around like 6 to 7 modules in this workshop. So we have the first one, it starts about, introduction to the workshop, which this has been designed for a self-paced one. So since we already covered what is workshop, what is doing it, so we can skip that. And the next challenge would be about creating an account in Pinecone, which we already did. We can move past that. And the third one is the where we will start with data loading. Again, the reason, so for our agentic AI to work, we need to create that persistent storage layer or a knowledge layer. So that knowledge layer is a Pinecone vector database where we will take all these 10K documents, convert them into vector embeddings and store it. So that's our, the model which we'll talk about it. Okay, so I'll pause for a few 1 or 2 minutes so that everybody is in that Instruct. Okay. Good. I see you all logging in. That is clean. Perfect. Okay, perfect. I believe no questions or concerns on Instruct, so I'll keep progressing.
I can, it says, please wait while we set up the challenge. It's been 5 minutes like that. So I tried to refresh my browser. Maybe I'll close the browser and try again.
Sorry, Rakesh, like what was your concern?
When I click start, I see, please wait while we set up the challenge, and it's stuck at that point. I don't see anything else.
Same for me as well.
Yeah.
Actually, you know what? Sorry, I see. Yeah, I don't know if I got it right. So
you see as stop again. So Instruct works on provisioning the VM resources. So for few, we have created some hot starts. That means you can instantly access it. For few, you might be seeing a wait symbol. So the VMs are being provisioned. So, but it should not take more than 1.5 minutes.
The bottom, there is a start button. There's a start button at the bottom. Just click that.
So once you have the start button at the bottom, that means your VM is ready. You can start the challenge.
It's opening the Jupyter and it's asking the password or token.
The Jupyter
one? You can stop right there. We're gonna work through that together.
Again, I appreciate you being self-paced, but we will walk you through. So how we are envisioning it for each module. Me or Jenna will walk through what is the module. We'll run the cells, and next we'll give 20 minutes for you to run through it. So that way you'll be comfortable. So please do wait there. We'll be there in a minute. Okay, so few things I wanted to share. One, if you have anything you want to talk to us, just raise a hand. One of us will look into it, and we will, see like what's happening. Or you can communicate to us using messages here, like the point here, and we can also respond in there. So that way we can make a one-to-one conversation instead of like the everyone. And in terms of instruct itself, in the first module, it's only instructions. So you don't see anything. So whatever you see this blank area, it's a terminal where you run the commands or anything. So you'll see blank for first two chapters, but from the third chapter, you'll see a terminal there. And on the right side, you have instructions. So it's a self-paced. So like, what is this workshop? You can like hide or unhide this workshop. So you have the instructions here. What is this? So right now it is talking about what is about Pinecone. Um, it's like Pinecone with AWS. So it's a small write-up. So what is Pinecone, what is AWS, and how it's been integrated. Again, the role of AWS here, what we're doing is, in our workshop, we are using a large language model for the response generation and also the agent part. So we'll be using Bedrock model. Again, you don't need to do set up anything. Everything is set up there. But just for information, so when you're running this large language model, we are using Claude model. So it's already been set up. So what are we building today? So it's a agentic AI RAG application with 10K filings of a company called Compaq. So what we'll cover in this workshop, setting up the Pinecone account, which is already done. So we will start with loading your data, loading the data into Pinecone index. Then the next module will show you how do you query with Pinecone and how it helps creating the context for the relevant question. Then the third one, the fourth one is main, the agentic AI application itself. So we will walk you through how you can create tools and how you can, invoke the tools, get the data. And fifth one, like whatever you saw, what Jenna showed to you on the web UI, so you can build that web UI. And finally, cleanup. Cleanup is optional. And this is for your reading. And cost of workshop, if you're running here, there is no cost to your workshop. But after this, we'll also share this link. You can have access to the code. So if you wanted to run your workshop, there are a few things that you need to set up, like model access and everything. So that will be charged based upon the respective consumption. Okay. So once you're done with the challenge, so you see a next button here. Once you click it, it will take you to the next chapter. So the first chapter was about workshop. And now I'm going to the second challenge. So click on the start on the right hand bottom corner. It will take you to the challenge. Even in this module, you don't have anything on the terminal because it is about setting up the Pinecone account, which we already did. So creating the Pinecone account, creating an index, creating an API key, and extra learning. So feel free to skip even the second challenge. Click on next here. That will take you to the next chapter. Now,
so we don't have to create the index here?
No, because we will create that from the notebook programmatically.
Okay.
Okay. Again, at the third channel, please stop because this is where the actual hands-on starts from. So let's wait a minute here so everybody is comfortable here.
Quick question. Will it be accurate to say the index is more sort of instance workspace where I'm working on? Where my work information stays, or?
Yes. So again, it's not exactly the same, but we can correlate to it. So that's where your information, your data stays. That's where your access control and everything happens there.
Can I have multiple indexes?
Yes, you can have in index million. Again, I don't remember, but you can have hundreds of indexes. And in an index, you can have millions of namespaces.
Thank you.
Okay. So having said that, what I'll do is now I'll pass on this to Jenna. Jenna will run you through the data loading pipeline. So should I share the slides, Jenna?
That's a good question. No, I think I'll just do it right in the platform. I want to share a couple of things.
Okay. So I went through this instruction.
Yeah, this is one of the things I wanted to point out.
Yeah.
In fact, why don't you unshare the slides and I'm going to do this live in the actual platform before I get going.
Oh, shall I stop sharing?
Yeah. Yep.
Done.
All right. So what Vamshi was just sharing as far as a slide was about how you can get help as we're going through this workshop. Very important. So we have the ability to actually help you through this Instruct workshop platform. There are a couple things that you can do. So you can raise your hand by using this little button here, or lower your hand, and you can type a message to one of us. We'll see this. And we can either chat back and forth with you or we can come on to Zoom and chat live as well. So you've got the raise hand feature. You've got this messages, which basically, if you click this button right here, it will open up this messages panel here, and you can say that you need help right there, and then we will see that. We can respond to that on the back end. We also have a couple of additional tools that we can use to inspect your workshop platform or even view your screen if we need to. And you'll have to like give us access. You'll have to confirm that you want to allow us to do that. But that's if we really need to go to that point. So know that we have options for helping you. So let's get back to actually building something because that's why we're all here, right? The very first thing we're going to be doing is loading some data into our index, and that's what this whole module is going to be all about.
Jenna, can you give a quick overview of the terminals there so that way people are
Yeah. Yep. Yep. So a couple things. I'll get there. I'm gonna get there in just a second. I want to talk through this, and then we'll do that as I start the actual work for it. So what we're doing here, we want to load that data that we talked about earlier, those 10K documents, into our Pinecone index, and as we talked about, we have to do some pre-processing. We have to remove some of that formatting, some of that markup that is just not interesting to what we're doing. We want the actual data. And once it's cleaned up, we're going to actually chunk the data. Oops, trying to make this a little bigger so you can see this image. So we're going to be chunking that data into smaller pieces that are they have meaning within that each chunk. So we don't want to embed an entire document all at once because that might dilute that meaning in the context that we're trying to access. But we also don't want our chunks to be too small because then we might miss some context. So we'll go through a chunking process. We will send those to our embedding model, which we're doing that through Amazon Bedrock. There was a question in chat just a minute ago about what we're using it for, Bedrock for. We're going to use the models that Bedrock provides. So we'll use Amazon Titan text embeddings to embed our data. So that's going to generate our vector embeddings that we put into Pinecone. And then later on, we'll use Bedrock to access an Anthropic model, Claude Haiku, to do our generation, to do our decision making as well. So in this diagram, we're sending our chunked documents through an embedding model. We're getting our vectors out of that embedding model, and then we're going to upsert those into Pinecone. So that's what this module is about. I want to talk through like what this is going to look like in practice through these different modules. So this module has kind of a description of that, but I'm going to talk through it here. You can see on the left-hand side here, we have the Jupyter Notebook server. And to get access to that, we have to do a couple of things. I'll walk through that in a minute. We also have the terminal. We'll do one thing here. just to get access to the Jupyter server. And then we'll be working through our notebooks in this panel, the Jupyter panel here. If you're not familiar with Jupyter Notebooks, I realize that not everybody might be. They are it's a Python tool that you can use to execute snippets of code sequentially. And so there will be code cells, there will be markdown cells, and I'll show you these in just a minute. That you can the code cells that you can execute. The markdown cells are just descriptions. Yeah, so let's the first thing that we need to do to actually get access to this server, because it's looking for us to log in, is we're going to go to the terminal tab, and you can click the link or you can click this terminal tab at the top. And we are going to run this command here. All this is going to do, I'm going to just press it. I'm not going to copy it and execute it. All this does, it's getting the token from our server so that we can log in. Next, I'm going to take that token. I'm going to paste that into this text box right here and log in.
Oh, sorry. Where can we find the token?
So you'll go in, you'll do the instructions are right there on the right-hand side.
Right.
So you'll run that command in the terminal. That will output a token that you copy and paste into that that
Oh, okay.
field. And not sure
Can
what's
you
going on
rerun it
here.
again?
What's that?
Can you rerun it, Jen, again? Jupyter?
Yeah. So this command here, something is going on. It's not. We're able to see the server. So what I did was I just highlighted this token, the one that it output here. And then in the Jupyter tab is where you're going to input that token.
Do we need to give the password too?
Nope, just the token. That's all you need to put in there is the token. I'm not. Are other people seeing that error that I was seeing?
No, Jana, you're the chosen one.
I'm the chosen one. Good. I'm glad I'm the only one who's seeing it.
No. So, do you want to try another VM, Jenna?
Yeah, I think I am going to try another VM.
Yes.
Vamshi, do you have this one started up?
Yes.
Like, could you
I
get
already
going
started
on
it up. Yes.
Okay, let's do that. And I'm gonna start over. I'm
Okay,
having
sure.
so many issues here.
I know. The live sessions. This is the curse
Yep.
of live sessions, you know.
All right. I'll let you go. I unshared, I think.
Cool.
At least you guys have your plan A, plan B, plan C, right?
Yes.
You never know.
Yes.
Okay, perfect. So let me share my screen here.
So as you are sharing it, right? So I added the token. It's asking for a new password before I say login and set a new password.
So it's logged in for me. It says model 01 data loading.
So do I just type in a password to move forward?
You don't need a password actually.
Yeah.
Oh.
I think one of us should maybe look at what you're seeing.
I had to enter a password and it worked after that.
Yeah.
The token or the password?
Both.
It's a
the password.
Yeah.
Okay.
So it's a token. It's not the password. I don't like what that naming convention. I can look into it quickly. But usually, again, if you're coming, do it again. So go to this, click on this terminal. You see this, Jupyter prompt. And on the right hand side in the instructions, expand the working with Jupyter notebooks. So you have like what to run, but simple thing is like you go here, you see, a command here, you see a copy and run option, just click on the run. So once you click on the run, it will generate a token. So that's also called as a password. Double click on this. So it will be already copied to your, clipboard. Go back to Jupyter and in the screen there, just provide that and click. You should see this 4 notebooks here. You should see this window.
Yeah, that's what I was saying. That in that screen, there were two text boxes, one for the token and another one for a password. If we leave the
Sorry, then in
password
that
empty,
case,
then
the
we can't
top
go.
one. So the top one is the token. So you need to plug in the token there and click enter.
I
Yes.
think,
So
sorry, there's
yeah.
a confusion here because right at the top of the Jupyter, that login screen, there is a box to enter the token. And then there is some description, and below that there are two more text boxes. One says token, the other one password. That's if you have not generated a token or something else, there is a
Yep.
password option. But ignore those two text boxes. Then
Yes.
right at the top of the page, there is a text. There should be a text box which says enter token. That is what I did.
Yes,
It worked for me.
that's exactly how it should
Thanks,
be.
Pranav.
Moving
Yeah.
to next model. I think I loaded the data.
Yes. So yeah, just hold on like a minute. So like we'll go through this one. Just checking if anybody still had issues accessing until or coming until this point. If you have issues, raise your hand. Like one of us could even get into your VM and look into it. If not, we will start running this module.
Okay, good.
Okay. So in this data module, so what we'll do is high levelly, excuse me. So first we'll start with declaring libraries because we need three sets of libraries. One, Pinecone SDK itself. So we will be loading the Pinecone. Number two, we want, again, as Jenna mentioned, we are converting the raw text to vector embeddings, which is a numeric representation. So we need an embedding model through that. So we are using Amazon Titan model through that. So we need Boto 3 module of AWS to run this APIs. And few others like few Python frameworks for us to run with this process. So all these libraries are installed with this in this first cell. So in Jupyter, you have a markdown cell which only contains the text, and you have code cells which you will run the cells. So in this notebook, we will run the code cells. To run the code cell, you can click on here, and on the top you see a run button here. You can click on this one, or if you are in Mac, shift with enter. So you can click on that cell with shift, press enter. So that will run this cell. So I just ran the first cell, which installed my library. So it's set to restart. So in the top here, in the kernel, again, this is an optional step. So in the kernel, you can go to restart kernel and clear output. So this will restart the kernel.
It's asking the Pinecone API key.
Yes, so I'll get to that point. So what I'll do is now I'll run through this entire cells. So you can just monitor or watch me here, like what we're doing. Then after that, we'll give you like 15, 20 minutes. You can run your own. And if you have any concerns, let us know. So I am starting with the library imports. The first cell after the installing libraries is my importing my libraries. Shift enter or like execute command, either of it. The next one is we are providing the Pinecone API key. So once you click on here, so here you see a small box which is asking for Pinecone API key. Now go back to your workspace where you have stored your Pinecone API key. Copy that and provide in this little box here. So I just provided my API key and click enter. So we are providing an API key, and this is the only input that you provide in the notebook. For the AWS access, we have already pipelined them, so it should be in this notebook. So the next cell, what we're doing is we are creating an index. We are just creating an index name, and in the next step, we'll create an index. So here index name, we are giving as Agentic AI with Pinecone and AWS. And next cell is specs. So it's a serverless specs. Okay. So this three cells completes the initialization of Pinecone. The next thing we need is setting up the AWS environment. Again, this is the text you need, but you don't need to worry. We we had it here. So once you run this cell, user access will be provided. So for now, just run that cell. Next one is initializing the Bedrock line. So that's where you'll call Titan model and also the Claude model. Okay, so self-description. So now next, we are creating a Pinecone index. So this little code module, what it does is it will check if the index is there or not. If it's there, it will skip. If it's not there, it will create an index in your Pinecone account because you gave the Pinecone API key, so it knows where to go, which account, and it'll create a index there. Okay. Okay. So once you create a Pinecone index, so you can run this next cell, which will shows the stats. Again, just overlook the stats because I already ran this. So I'm rerunning this. So you'll see the total vector count here. So which is 802 vector count. But in your case, you will not because we have not loaded the data yet. Another way you can go and check the indexes, go to the Pinecone console where you have created it. Log into your Pinecone console. On the left-hand side in the databases, click on the indexes. You can see the indexes. Now, this is the index we just created from the notebook. It's Agentic AI with Pinecone and AWS. Once you click in, it will give you the details. So we are using cosine metric with 1024 dimensions. And this is the host endpoint, which is calling. You can see cloud, region, and the type. So other parameters. In my case, I have loaded the data. So you can see the data here. So I'm just showing one record sample. So each one has an ID.
Please, I can't see that index that we created on the notebook.
Did you log into your Pinecone account?
I just need to refresh it. It was
Yes.
not.
Okay.
Sorry. So you go to just refresh this page. You should see the index there.
Okay. Thanks.
Okay. So in your case, you'll not see these records. It will be empty, which I mean, I'll come back and I'll explain the records once we do the data loading process. Okay. So in loading the data, so we are doing it in 4 different steps. One, we have different 10K files, like almost like 8 to 10 10K documents. So we have already, unzipped it and had it in this VM. So what we'll do is we'll take each document at a time, parse the text out of it because it's an unstructured data. You have a text summarization and you have tables. So we'll parse the text from, the text summarizations and also the tables, and we will chunk the data. So step number 3 is chunk the data and create vector embeddings. So each chunk will become a vector embedding. So to analogy, like each chunk, you can think like a raw text. So that will convert into vector embedding. Like since we are doing a 1024, you will see 1024 this numerical representations. It's an array. It is representing the data. So in the last step number 4, we will upsert. We will load those vector embeddings into the Pinecone vector database. Step number 1. So we are parsing the data. So each command here, it's like it's getting the data. So the filing years are from 1994 to 2002. So we are getting the data, and all you need to do is just run the cells one by one because the data is already there.
I got stuck in this entering the Pinecone API. It's asking the input. The cell is asking the input.
Yes. So once you click on here, right, you'll see a little box here popping up. It will ask
that
for
box I'm putting the Pinecone API and trying to run the code, but it says still.
You have to hit it. You have to hit enter.
Hit enter, please.
Okay, I entered.
And once you hit enter, you'll see like this: enter Pinecone API key with dots.
Yep, it was there. Yeah.
Yeah, you can proceed to the next steps.
Oh man.
Okay. So the code is self-explanatory. So all we are doing here is like passing the data because it has, different formats, unstructured data, and also unwanted tags. What we are doing is we are extracting the data, parsing the data. We are cleaning up the data and we are formatting the data. So this all in this code here.
Yeah, can you just explain how like the real significance of doing that? Because what would be the consequences of just taking data that is very noisy and has all of these, characteristics and use it for a RAG solution?
Again, when we say noise, right? So here in this case, it would be like the headers, like kind of special characters and everything. And for us, in our case, special characters doesn't add anything. So what we are doing is we are trying to remove it. So that's the very basic level of data cleanup we are doing it. But apart from that, what are the majorly doing is we are taking a text and we are checking it up. Why do we need to chunk up? You can take the entire document, create a vector embedding and store it, but it will lose the context importance. It will lose like what are the important, once we have the more data, the entire context of that will be lost. So that's why what we'll do is we'll chunk it to a reasonable size. So that chunking is nothing but cutting the data into certain small pieces of it. So that way you are trying to hold the relevance of the data on the context, and also at the same time you are creating a vector embeddings of it. Again, I'll talk about like why the chunking, why chunking and how many types of chunking that you can do. So mainly it's related to the retrieval accuracy, because the more the data you have, you lose the context. The less the data you have a lot many number of vector embedding. So you need to find that sweet spot. Okay, so let me run this table. So once you're running this, we're also printing it just for your reference. Like how does like table data look like? And in this case, I am parsing all the entire 10K. So the entire 10K, like the text data looks something like that, like this one. Okay. So keep on going with running this. Okay, now chunking strategies. In this use case, we are using a fixed size chunking. So what I'm doing, so we are taking a 1500 characters as one chunk, and we are breaking that text apart and generating it as one chunk. And even there are like methodologies like where you can overlap. Let's say we can spill over from the previous chunk and the next chunk. So that way you're not losing that context. Apart from fixed size chunking, you have semantic chunking. So you can group the statements based upon the semantically similar meaning, or you can have a sliding window methodology, or you can have a hierarchical chunking, or even you can have a domain specific chunking. And this all depends upon what is your use case, what is your data, and what is your, context, like how you want to do it. And our suggestion is, recommendation is, based upon use case, try different techniques, try different chunk sizes. So that way you'll find a sweet spot where works best for your application. So in this notebook, you can find more reading about it, like what is best for each use case.
Vamshi, can I ask a question?
Okay. So once pass through that,
Vamshi, can I ask a quick question? Sorry. On chunking strategy. So if your source data is not completely unstructured like PDF, but say a JSON kind of data, is there a recommended approach for the chunking strategy for that kind of data?
Yes. So if you are like a domain specific or structure level chunking, right?
Oh.
We would like to use like the tags. If I'm looking at HTML tags, you have headers, subheaders, and the actual paragraph, right? So that you can use as one of the chunking strategy, because the data has been bound into certain paragraph. It has certain specificity. Even in JSON, like when we look at the data, it's been bounded into a certain key value pair. So if that key is like more relevant in your case, use case, then take that value of text and make it a chunk. So we need to try, Pranav, like depends upon, as I said, like use case versus like what you wanted and how you wanted to maintain the context.
Yeah, I didn't notice this. This is really helpful. I'll go through this. Thank you.
Sure. Go ahead.
Vamshi?
Yeah.
Sorry, go ahead. Whoever was.
Yeah, in the previous step, it mentioned as chunking by table and text.
Yes.
What does it mean by, what is the differentiation there? How did
Okay. So in the 10K, right, there are two different, again, here is like we are only taking the paragraphs or tables. So tables are something like you have a table header and you have columns of the data. So this is differently perceived when you're looking at a continuation of text. Let's say, let me go scroll up. Okay, so this is the continuation of data, like say paragraph of data, right? So what we did is, again, these are all ETL practices. It has nothing to do with vector database or anything. So it is about data parsing. So what you're doing is in the 10K, we are looking at grabbing all the tables together, grabbing all the text together and try to chunk it. So that way we are trying to apply different techniques for different types of data. But again, this is purely depending upon how you wanted to process your data. Nothing to do with embedding or nothing to do with vector database.
Okay.
Hey, Vamsi, quick question. There's some good explanation there, and I can take this offline. My simple question is there a feature or capability in Pinecone dashboard where I can evaluate different chunking options before I can say, okay, this is the right chunking option for my use case?
Actually, unfortunately, in the Pinecone website or console, you don't have, but you
Okay.
you can do with the notebook itself with using the SDK. So what you can
Okay.
do is you can try here in this cell. What I'm doing is a text chunking, which is fixed site chunking. So I'm
Yeah.
taking 1500 words and doing it, and I'll try it. And also, I would encourage is like create multiple cells, create one type of each. Another would be semantic chunk, another would be sliding window. Load into
Right.
different indexes.
Yeah, no,
Try
I get it.
querying.
I understand. I was looking for like, is there something automated based on my data set system, Pinecone kind of suggests me, but that's okay. Thank you.
Yeah, we don't. Yeah. Okay.
Okay.
So, okay, now let me complete this like 3 cells, then I can take questions and also you can have time to run the cells. Yeah. So I'm at this like transforming data into records. So we are like whatever we processed in the ETL there. Now we are trying to accumulate them, all the chunks by text records and by table records. Go ahead and run it. And till now we have done like ETL part of it. We parse the documents, we chunk the data, and now we have the document chunks. Now in this step, which is a crucial step, we are converting the raw text into vector embeddings. And once we create the vector embeddings, we are upserting them into index. So this little helper function will do the like text embeddings, which will call the Bedrock Titan model and create it. And this little helper function will do the upsert. So again, you have, descriptions here. Okay, so now this is the command which will actually run that, create embedding and upserting. Go ahead and run it. So what's happening on the backend? So we have created all the chunks. So each chunk at a time, it will invoke the Amazon Titan model, generate a vector embedding, and it will grab that vector embedding and it will upsert into Pinecone.
Are
So
there
this happens in a batch.
are there different different tools to generate the embeddings, and is there like do certain tools work better than others as far as just the quality of the embeddings, or are they all equal?
I would say yes. So there are different models, not tools, models, because you have Amazon Titan models, you have Azure models, you have GCP models, or even OpenAI, Anthropic, different embedding models. So each depends upon the type of the data that's been supporting in. So it really depends upon use case and also the type of data that you're dealing with. So you can try different embedding models. Oftentimes we have seen customers using OpenAI models, the text embedding model. For this workshop, we use Titan, but again, you can use your choice of embedding model.
Okay.
Where can we see the data directory from where it is reading the data?
Yes. So once you have done with this notebook, now we have uploaded 802 vectors into our vector database. Now I'll switch to Pinecone console to show you how the record looks like. Okay, so I'll first start with namespace. So this is our index that we created, and this is our namespace. In namespace, we have specified default, but you can use any namespace name and you can create it. So if you don't specify namespace, it will go to default. So in the browser, so you have the records. So the sample record is ID. So we are creating this ID in this format in our notebook. So compact underscore the year hash the text 0, like the sequence number of the text. So this is the ID. And do we have show values?
What is our source documents, from where it is reading the source?
Source document is the one which Jenna has first shared. So in this, right? So if you in the VM, if you click on this folder, so you have the entire framework that we added here.
Okay, got it. Okay.
So here you have data. So in the data, there's a folder called Agentic AI. So this is the text 10K files that we had it here.
Okay.
Okay.
Right. Thank you.
Sure. So going back to each record. So namespace is default. ID is the one which we created and which we asserted. Values are the vector embeddings that's been generated. And in the metadata, what we did is we added chunk text. What does a raw text looks like? So this was the raw text which were converted into vector embedding and stored. Apart from that, we also added two more metadata fields. Chunk type, is it a text or a table? And filed year, 10K year. Metadata is up to you. You can implement how many ever your key fields you want. So this is called as a key. This is called as a value. Why do you use metadata? You can for multi-purpose. So you can see the tags of it. You can do a filtering, because when you're doing a querying, you can filter with, okay, give me only the filed year of 1994 or 1994 and 1995. So you can apply metadata filters there. So that's where the metadata is very key when you are upsetting the data. So values, let me show if I can. Okay, I can't see the values here. So let me. Okay, sorry. I don't have a notepad here, so I'm just pasted it here. So this is how the vector embedding looks like. I'll quickly go there. So for this text, which is it here, when we converted into a vector embedding model, so it generated, this is the vector embedding. So it is like 1024 vector dimensions, and it's a numerical representation of that raw text. Okay. So similarly, you have the records here. So there are total 802 records in this index.
Vamshi, so since we embedded just the text out of the 10K documents, right? So how does it know that this is from this year?
This is from this year?
Like this, if I ask the question about specific year, like 1995.
Yeah. So the two things. While we're upsetting the data, we added that metadata. So if I go to this one, right? Okay. So if you see here, so metadata is something that we are defining during the data loading process. So we said which year, type, and chunk text. How this will be used in Pinecone? When you're querying, right? In the next module, we'll see we are querying it. When you're querying, you can specify as a filtering. I want only data from filed year of 1995 or 2001, something like that. So when we are doing that query processing, so we'll try to match the method of filtering and only get the data that you wanted.
Okay, we have to put an additional filter of year, and then it'll do a semantic search after that.
Yes.
Okay.
Okay, so I'll stop here. I think we are running late, but that's okay. So let's take 5 or 10 minutes, run through the notebook. And once you complete this notebook, you should have the data in your Pinecone index. So we have 3 more modules. So we'll try to speed up a bit. So let us know once you're done.
And if you have questions, feel free to either pop on the microphone or let us know in chat, because we're all here to help you.
So, Vamshi, one more question on my Pinecone score on the portal. I can see there is a score associated for each record. What does the score stands for?
Okay, yeah. So this is the semantic search, similarity score. So for the given query, so what is the matching? Because all we are trying to do is get the nearest neighbors for that query or for that, data. So this score defines how closer is this data related to the query. In this case, the console is doing a default query. Now in the next module, I'll show you like how the query for a given text, how the closest matches are.
Okay.
So yeah, in the interest of time, we will move to the next chapter in 5 minutes. So if you want more than 5 minutes, let us know in the chat. If not, at 1:58, we'll move to the next chapter.
Oh, do we have to connect to the indexes? Like there is a button connect. I'm not seeing this index records.
Inside the console,
Uh-huh.
you don't need to. Once you get into your console, right, the main screen, on the left hand, you have databases and you see indexes. Once you click on index, it's here. You don't need to connect.
Oh, yeah, I can see like this, but you showed me something
Just
different.
click on here.
Oh,
Once you
okay.
click on here, you'll go into that index.
Got it. Thank you.
I think connect will give you a sample code.
Oh, okay.
Yeah. Okay, 2 more minutes. But if you need more time, let us know. If not, we can move on to the next chapter, next module.
So the different type of chunking, it's how I set it up rather than having a type chunking strategy and selecting that that's not an option, right?
Sorry, can you please come back on that question?
Sorry, you were stating about the chunking strategy, various types of chunking, right? You showed fixed and other things. So what I was wondering, if there is sort of a drop-down list or something saying that, okay, this is a chunking strategy I select. It's not that way, right? I have to define it through the code that which chunking strategy I'll be using it, right?
That really depends on chunking strategy because it's like a experimentation only. We'll know what is the best chunking strategy that works for your data because there are many variables in it. Like what is your data? How is your data spread out? And what is your access patterns that you're trying to query the data? So these are like few chunking strategies, but we would recommend is try different things because the most common thing used is fixed chunking, and the next best one is semantic chunking. So what you do is you, take semantically similar paragraphs and group together and do it. And there are few libraries which does that, and unfortunately those fall beyond the Pinecone. But we are happy to provide you like resources where you can do that.
So just to summarize what you just said, because I had a very similar question to what the gentleman just asked. There's libraries out there where you can go find the code to do the different to execute the different chunking strategies. You don't need to, like, if you wanted to do the overlapping one as an example.
Correct.
There are few libraries, yes, open source. I don't think so for the open source, but there are a few libraries which does it. But that is beyond Pinecone. Outside of Pinecone.
Right. Okay.
Yes.
Got it. Thank you.
Sure. So I think we are on time. So I hope like everybody was able to go through this notebook, run the notebook, and load the data into the index. So what we'll do is we'll go to the next module. So on the right-hand side, once you, scroll all the way down, you'll see next button. So click on next. So we'll proceed to the next module. Okay. So once your module is ready, you'll see a start button blinking here. Click on start.
What's the LLM model we used in this? I forgot to visit.
Amazon Titan for embedding, and Anthropic Claude Haiku for the response generation, which you will see in this second module, module number 2. So once you click on the start, so again, the layout is similar. So you have a Jupyter terminal and you have a terminal. So we will be in the Jupyter. It should directly redirect you to this module. If not, then just do the same process, like give the token and you should be in this module. Okay, so on the right-hand side, you have instructions, TLDR, like what you're doing in this module. So in this module, what we are doing is we are doing a query. Whatever data we loaded into the index, into the Pinecone, we'll run a sample query and we'll analyze the query, like what are the different things. And we'll also see the output, like how the semantic search is done, how the document chunks are retrieved, and how do you frame this as a context for the large language model to provide a response. And in the next module, which is agentic module, that's where you look into different tools like Pinecone tool and a web search tool. And you will implement this strategy of getting the context from Pinecone and applying the agentic framework. Again, feel free to go through those instructions. So data retrieval, augmented generation, and the pipeline. So what's happening in the pipeline, which I'll go in a bit now. Okay, so same process. I'll go through high level of the sections in this notebook and you can follow along, or you can go through it, or you can run on your own. Okay, let's restart the kernel. Okay, so one quick step you need to do it here. Okay. Get your API key, grab your API key, same step as we did in the previous notebook. When you come and at this cell, when you run it, give your API key, paste it here and press enter. And define your index name. This is the index name we created. Then run this cell so that way it could get the Amazon access. We are initializing the Bedrock client. Okay, so for embedding model, we are using Titan embed text. And for generation, LLM response generation, we are using Claude 3 Haiku. Okay, so let's see how many stats of the index. So I just did a describe index stats. Now it is showing 1024 dimensions and total vector count is 802. So you should also see 802 vectors. Now, what's happened in this notebook? So now when you wanted to ask a question like what is the company Rob founded or what is the revenue in 2001? So that's a natural language text. Now for us to do the semantic search, we need to convert this text into vector embedding. So that way we can do a semantic search, like find out the closest distance and do the semantic search. It brings the nearest neighbors. Step number 1, using that query, we will, using the embedding model, which is the same embedding model, Amazon Titan embedding model, will create a vector embedding. So something it looks like this. Again, the previous embedding that I showed. So once we have the vector embedding, so what we do is we do a query into the Pinecone. So this is my vector embedding. Go get me nearest neighbors. So we call it as a top k neighbors. So top k is configurable. You can get 10, 30, or even 1,000 neighbors. So what it does, it does a nearest neighbor calculations, and it will go find out the nearest neighbors and get it to us. And when it gets to us, we have the document chunks. So we use the chunks and create a context And now we will instruct the large language model. Hey, here is a prompt. Prompt is a set of instructions, like how do you, respond to my question. Here's the context. So this is the context that I got from the semantic search. And this is my question. Look into this context and answer my question. Now, large language model will look at the context and provide a response to it, which will provide to the user. So these 4 steps now we'll do in this notebook. First one, it's a helper function to create an embedding for a query. Next one is a helper function to create the semantic search. Now, let's run that semantic search. Now, query changes in Compact's product offerings and their impact on sales. So we're asking them, like, what are the product offerings and the impact on sales? So let's do the semantic search. Okay, so now we got the response. Let's see the response. So based upon that question, it gave me the top 3 matching chunks. So the first one is this ID, and this is the text associated or closest to the question. And this is number 2, top closest. And this is the top 3 closest. And this is based upon the similarity scores that we saw in the index. Now we can print the entire thing, like the query outputs, and see. So it has the similarity score. So based upon that, we can sort it which is most closest. Now we are taking this text, framing it as a context, and providing it to a large language model. Let's see how. But before that, let's do a re-rank, because we know it returned me the nearest neighbors, but I wanted to re-rank for efficiency based upon my question. So I'm using the Pinecone re-ranker. Okay, so I'm re-ranking because we wanted to get the most relevant information to my query. So using a re-ranker, so we re-rank. So let's see like what is, so initially Compact 2002 text 71 was my top one, but once I re-ranked,
Can somebody be
Compact
put on mute?
1999 text 42 was most relevant to this. And in the same way, when you're applying a query, you can apply metadata filter saying that if you wanted to particularly filter on certain filter, you can mention that filter condition because it has in the metadata and you can filter the data. So these are the results after re-ranking. Now, augmentation, this is where we are forming the context from the text. Okay. So 3 important components that we are providing to large language model is first one is prompt. Prompt is a set of instructions that you are letting the large language model how to respond to your question. Number 2, the context itself. So since we did a semantic search, now we know for a given query, like what is the most relevant information or most relevant facts. We pack them as a context. So that way, large language model no need to go and look into its knowledge or memory. Number 3, the query itself. So once we provide all these 3, now large language model will look into the query, look into the context, and provide a response. Okay. So this is helpful.
Vamshi, so re-ranking, every time we will do the re-ranking, right, for this RAG?
It's up to you. So re-ranking is an additional option. So if you feel re-rank will improve your results, we'll do. We often recommend to re-rank because it will get us the results. But based upon my query, what comes first? Like what is my top priority? So that way you can, help in concisely prepare your context.
Okay.
Yeah. So this was the response generated. So for the question that we asked, like the Compact's offerings and how it impacts sales. So this is the response, we got it. So it went through that 3 steps: creating better embedding, performing semantic search, preparing the context, and providing to large language model. Now this time, like model is more specific because it has all the facts. It has nothing to do magical. So you have facts, you have question, all you need to do is answer. Okay. So final code is again putting all this together. So we are doing a different one, or you can change the question and ask. So if you want to change the question, go to the query, change it here, the query should be in a double quotes. And once you do it, just run this. I'll also change the question and do that. Okay. Okay, let's try. So what are the sales? What is okay, so I changed the query. So it goes through the process now. Let's see. Okay, so according to the information provided, Compaq reported constant revenue of 33.6 billion in 2001. So if you want to test, let me check. Okay. 2001, but can I open it here? Okay, let's see if this is there. 33.6. Okay, I'm not sure. Complex actively engaged. Let me look at a summary. Okay, surfing through the unstructured data. Where do I find it? I love that compact. 33.6 billion. Yeah, I think I have it here. 2000. Am I saying looking at the wrong document? I said 2001. Okay, so play around. So since it's been live, so 32.4, let's look at here.
Yeah, my kernel is having a problem. I don't know. Somebody can help me.
Yes. So what was the problem?
Even I entered that API key. It's not, after pressing the enter, it's not proceeding further.
Okay. Did you paste that one and click enter?
Yeah.
Okay. So let me quickly check through it.
Yeah, same issue. I know Jenna's telling me the same thing, but I don't know why it's stuck.
You have to manually go to the next cell and press run. The Jupyter notebook doesn't automatically go to the next cell after you press enter.
Yeah, I'm pressing that manually, selling the enter, pressing that cell button only. Run the cell and advance. Shift
Okay.
enter, right?
So let me know who has issues so that I can just log in and check.
It's me.
Giri.
I'm logging into, I'm trying to help crawl out.
Thank you.
Yep.
Okay. So Jenna, are you taking care of Giri?
Arjun has been trying to get information from Giri. I think I'm looking at Kroll and I have access to do that now, I think.
Okay, fine. So Ranga, I think you shared your, so you raised your hand. Anything that you
Yeah,
need help with?
on the re-ranking model,
Hmm.
can you explain me that is not the GPT or anything, right? Where is that came from? BG re-ranker?
What BG, right? Okay, let me go back. So in re-ranking, there are a couple of models where you can do it. Yeah, so this is the BG re-ranker. Again, we are using this, but it's up to you, like whichever, I mean, works, because they are like three types of re-rankers. So BG re-ranker, Cohere re-ranker, and Pinecone re-ranker. So in the API call, if you mention what type of model you want, so that will hit this endpoint.
So what are these models based on? Are these based on top of the GPT or something?
Yes, so these are trained on specific data, and it has, again, I don't have out of my top of my mind, I don't know exactly which model is good for what, but these three are being trained on a different types of data and have different specifics. So Cohere, Ranker, or BG or Pinecone. So based upon that, so you can choose which re-ranker and invoke it.
Can you think of these are fine-tuned models for a specific purpose?
Yes. Okay. So these are fine-tuned models for a specific purpose on re-ranking. So its specific job is looking at the query, looking at the received results, which makes more sense. So it will re-rank based upon the closer similarity scores.
Okay.
Yes.
Vamsi, how
Yes.
it is grabbing the AWS credentials?
Okay, that's a big story. So if you look at Instruct, right? So it's a platform where you can run the workshop. So for us today in today's workshop, if you want to run workshop, so you need Pinecone, you need large language models. So for large language models, we choose AWS, and on the back end, what we are doing is we are doing a customization where we are getting you the access credentials and providing in your notebook.
Okay.
That we can run it.
Got
In
it.
case if you're running on your own, you need to provide the access key and secret access key so that you can run those models.
Okay, in the backend, Pinecone have a AWS cloud environment, and with that API, we are getting all the information.
Yes, that's correct.
Got it.
Again, that's for the workshop, not in general. In Pinecone, by
Okay.
default, doesn't have it. For this workshop, we are plumbing those.
Got it.
Okay. Okay.
Hey, I'm
So
having an issue on line 15. Once I re-rank and run it, I'm getting exception.
what is it? Is it a limit exception? Because in today's workshop, you might see a few limits because we are almost 60 people running in parallel using not for Pinecone, but at least for AWS, you should see. And in web module, there's a DuckDuckGo module you might see because those are external and have a limited API limits.
Well, the exception says invalid type or value for variable documents.
Okay, so did you make any changes in this one?
Nope.
Nope. Did you run all the cells?
I ran all the cells until, yep.
Okay.
And that's up until step 3, rank the results. Yes.
Okay. What is your VM?
Yeah, I checked. I ran everything. Yep.
BipLab. Okay, so let me log into yours. Under what name you are? I mean, BipLab data. Like, I can't see your machine here. What is the name that you gave while you're logging in? I see you now. Okay. Can I access your sandbox?
Yes, please.
Okay. Give me a second. Okay. So while we are looking into it, Jenna, would you like to start the agentic one because we have only 45 minutes left?
Yeah. 1 minute. 1 second.
I think Jenna, I'm good. I think
Okay, good.
Yeah.
Okay, we figured out some of the API key stuff. Agentic stuff. Let me just, I want to share my screen again, but I've got things moving around a bit. So we're going to move on to the agentic module, which is the third main module that we'll look at. I'm going to request screen sharing, Vamshi. Okay, it looks like you can all see what I'm sharing. So in this module, so what we've done so far is we've loaded all of our data in, we've done some simple querying in the last module and some simple generation there. And now what we want to be able to do is actually access some more authoritative data from our Pinecone index, and we want to do that through a tool. We also want to integrate this web search tool that I mentioned earlier. And so in this module, what we're going to be doing is we're going to implement both of those tools. One for the Pinecone semantic search that I mentioned, and then the other just a simple web search. And then we'll have this main function that will it's called run agent. It's kind of the core function that we're going to be building out here. And it's going to orchestrate all of this work. And so it's going to defer to our generation model, Claude Haiku, in order to do the decision making and the reasoning. And so it's going to decide if, when, and how to actually invoke the tools that we're creating. And then it will also pass the results. We'll pass the results of those tools back to the model so that it can generate the final output or decide if it needs to call another tool or gather other information. So if you should be able to see my screen right now. I have module 3, Agentic RAG, open in the notebook. And the first thing that we'll do is I've already gone through a couple of these steps just to get some of the libraries loaded and my API key loaded as well. So as you kind of step through, we're going to do the same API key as we did before. So when you execute this, you paste in your API key and you press enter and go to the next cell. I think that's where that's tripping people up because it's kind of a weird text box that you see there. I admit that I feel it's weird too. And then we'll go down and again, we're using the same index as we did before. And we can see that we have, in my index, I have 802 vectors. You should probably have about that. But what we're gonna go through here is we're gonna first build out that first tool that I mentioned. In this case, we'll just do that web search tool first. And you can read through some of this on your own. Again, we'll give you access to all of this code and all of these instructions after the workshop so that you can go into it in more detail if you'd like. But we'll go through implementing this first tool. So in this one, it's just as the name of the function is just the web search function. It's the actual tool itself. And so here it is using DuckDuckGo search to execute a query against the internet. So I'm going to define that function. I can execute a quick query about what is the capital of the United States, and we get these results back. So it's very simple. We can see that that's working right now. We're going to add this one tool into our functions map, and this functions map is going to be what our run agent function knows which tools to use, and we'll pass these tools, this list of tools, back to the model so that it has access to the information about the tools. We also need to define this tool schema, and this is information about the tool. So it's going to be the name of the tool, which function is actually going to be called. The description says like, how do we use this tool? So in this case, this is super simple. Searches the internet and retrieves content related to the input query. Nothing fancy here. It just is a simple web search tool. It also, the spec also defines which parameters this tool is expecting. And so in this case, it's the query string that we're searching for. So again, this tool specification, this gets sent to the model so that it can decide, should I use this tool? How should I use it? Let me execute that one. So we have one tool. Now we need to define a system prompt, and I'm not going to go into too much details here for the system prompt because we're going to get one that's a little bit more custom in a little bit. But just know that this system prompt is saying, hey, you have a tool to access. You can use this tool to answer some of these questions, and here's how you should answer them. Again, we'll talk through that a little bit more in detail in a minute. We talked through how to get access to AWS in the last module. Vamshi talked through that a little bit. You already have access to that account. We'll use the same account. We're just setting some environment variables for these notebooks to have access to. Again, I think we saw this a variation of this in the last module. So we are initializing the Boto 3 client, which is the Python AWS SDK that allows us to interact with Amazon Bedrock. And then we're just saying we're going to use this generation model, Claude Haiku, and then an embedding model for Amazon Titan Embed Text. Okay. Next we are going to define this send conversation to Amazon Bedrock. This is just a simple call to send. We're sending the model ID that we want to have used for generation, so that generation model ID for Claude Haiku. We're sending our entire conversation. When we call this function, we'll be sending the conversation. So if you're having some back and forth with this agent, then you'll be sending that full conversation. So there's a point at which we'll want to reset that conversation, and we'll show that in a little bit. It passes in the system prompt because, as I mentioned, like those are more instructions to the model so that it knows how to interact with us and with our tools. And then again, the tool config, like I mentioned, that the tool specification is how the model knows like which tools are available and how to interact with them. So a simple interaction here. We're going to send our query to Amazon Bedrock. Which company did Rob Canyon co-found? And we can actually see what the tool response is from Amazon Bedrock, from the Claude Haiku model. So here we can see it comes back. This is the full response from the model. But here is just the one part that is about which tool to use. It's saying this interaction requires tool use. We need to use the web search tool, and this is the query you should pass to the web search tool. So now we can actually we can invoke the tool and send that response back to the model. So here again, like this is which tool to be using. The tool here where it says searching the internet for Rob Canyon co-found. That's the actual that's the tool is getting called through. Oops. Hang on a second. Okay. So in this function or in this block of code, we are adding our response from the assistant or from the model back to our conversation. We are invoking the actual tool here. So we're using that functions map we defined earlier to figure out which tool function to actually call. And then we pass in the input that we got from the model response. And then we get our response back from the tool. We put that tool response into the conversation as well. So all of this, we're just building up this conversation, which acts as the context that we're putting into the model for future conversations, for future interactions. So now we send that back to Amazon Bedrock. We get our response back, and we get that final output. So we can see that we invoked the tool. This is the response. And it looks like our web search did not return a very good response. In fact, it's executing a search that is coming back with stuff like fishing rods or lightning rods. And so we would need to actually like tweak this a little bit, potentially tweak the system prompt a little bit, which we'll do in a minute. And I think we'll be able to fix this issue. But what's happening here is it comes back with information about fishing rods, not the actual person we're trying to get information about. But it is telling us that our final model response is here, but the output, the interesting piece about this is that our model is now telling us it didn't have the right information. It couldn't find the right information, so it can't answer the question. So that is unfortunate for the situation we're in. Hopefully, we can fix that in kind of this next step. To fix that, we tweak the system prompt a bit, and we might tweak some other things with potentially maybe using a different generation model. Okay. The next part of this module, we're going to set up that second tool. That second tool, again, is going to be our Pinecone Semantic Search tool, or we call it Pinecone Vector Search tool, but it's executing that semantic search. So we have our specification. This description of this tool is pretty lengthy here, and we're just saying what information can you find in Pinecone. We're giving it very explicit information about there's documentation from compact financial filings from 1994 to 2002. To answer any questions about financial information, you go to use this tool. And again, it also tells you like how to prepare that search query as well. Like the parameter in to the tool is the search query itself. And then similar as before, when we want to search our Pinecone index, we need to embed our query. We need to create an embedding for the query so that it can do that comparison. And so this is just our, I think it's the same function as before. And now here, this is the actual implementation of the Pinecone vector search tool itself. We've seen some of this before in the last module. We're just wrapping this in a tool function and telling the model that you can use this as a tool. If you decide you need to use the Pinecone vector search tool, this is what we will run. So this here isn't really new code. It is just redefined in a tool function. I mentioned the system prompt. And so in this one, now that we have two tools, we need to give the model more information, more explicit instructions about how to use the tools. And so we've got some information here that says you are equipped with multiple tools. You can use one tool, you can use both tools. You might use them in parallel, which I don't think we have implemented here. You might use them sequentially to complete a question. We have information on tool, like the specific tools here on how to interact with the Pinecone vector search tool, how to interact with, or more detailed information about like when you would want to interact with a Pinecone vector search tool or the web search tool. This has been this here tool guide selection examples. Again, this is just more information on how the model should decide which tool to use. We're giving it some sample queries, sample generic queries on if you're asking about a company revenue, use the Pinecone vector search tool. So that is the system prompt. Let me get this run. And then this run agent function, this is the big function. It's the orchestrator of the whole thing that we've been building up to during this entire workshop. So what it does is when you pass in a query and potentially a conversation, either an empty conversation or a conversation history, it's going to go through here. It's going to initially send that query to Bedrock. Maybe it can answer that question right away. Maybe it has decided you need to run a tool. Here's how to run that tool. So that's what this whole while loop is about. And I'm not going to go through each piece here because, again, we've seen a lot of this code in various snippets earlier or in the previous module. But this block here is the piece that's calling that tool, the tool function and passing in the query. And then at the end, again, we send that that tool result back to the model. So it can decide, do I need to run any more tools? Do I need to gather any more information? What is my next step? In the case of what we're talking about today, often the next step is generating the final output, the final response. And so we have that printout here. So let me get this one run, and then we'll work through a couple of these example functions. Okay, this first query, this is simple, just a simple, which company did Rob Canyon co-found? I think this is the same exact question I asked earlier, that when we just had one tool. So right now, we'll see if it does what it needs to do. It has more information. The model has more information now using that from that system prompt about how to invoke that tool, or how to construct that query. So it's actually asking a different internet search query here. So we should get better information about which company was co-founded. And it looks like we did. One of the results is Rob Canyon co-founded Compaq. It goes through that while loop. It's comes back with the full response here. And we can see that final output is that based on the search results, Rob Canyon co-founded Compaq. So it only did one tool here. It executed that tool better than that initial one that I showed you. But we can go through a couple other ones here. I'm going to show multi-step tool use. I think this one should demonstrate that. So we're not passing in we're starting the conversation over here. But you could pass in the conversation if you wanted. But to demonstrate this one, we'll start with a new conversation and ask, what company did Rob Canyon co-found, and what is the revenue of that company? So we can see that the first tool that it's telling us to execute is the web search tool with, again, the same query as it decided earlier. It sends that the search results from the internet search results, the web search tool, back to Amazon Bedrock. The model through Amazon Bedrock comes back and says, we're going to use another tool. And in this case, we're going to use the Pinecone vector search tool. So it's starting to answer one part of the question. Now it needs to answer the other part of the question. So it is going to, it should answer the rest of the question. Here we go. Calling Pinecone vector search tool. Now that it knows the name of the company, it's passing in the query of Compaq 2001 revenue. Sends those results. We can see those results are in here. We send those back to the model. More results here. And our final output is according to the search results. Rob Canyon co-founded the company Compaq, and the revenue in 2001 was $33.6 billion. So you can see that the model is now deciding which tool to use and when and how to use it, whether it should use multiple tools or not. I'm going to stop here. If you're rolling along and just running through, go ahead. Are there any?
Jenna, question here,
Yeah.
right? When I look at I know you wanted to illustrate the example of using the multiple tools. That's why intentionally we passed the conversation as blank, right? Because if you had sent the original context, the LLM probably already had the response and it would not even use the tool. It would just give the answer. Is that fair?
Yeah, exactly.
Okay.
If I had just, I'm trying to save a little bit of time. So
yeah. I just mean sure, because I was just looking at the parameters and then I was like, okay, you blanked it out. Whereas in the previous one, for the demonstration, we were maintaining context. So if the context is self-sufficient, the LLM can just respond back. It doesn't need to use a tool. Got it.
Exactly. Yeah. Any other questions? How are people doing?
So Jana, in the both cases, in the previous one, the web search tool failed, right? It recorded response like some fraud, right? And then it went through Pinecone, right? And then
in the very first example, the very first query where we only had one tool, it failed because it didn't have a good enough query to execute the web search.
Okay. And the second one, where basically the tool guide is driving the everything, right? The we are articulating to LLM what you're supposed to do. I think that's the
so it's a combination of a couple things. It's a combination of the tool specifications that we defined that talk about the description and what the query parameters are to that tool. In our case, it's a query. A combination of that plus the system prompt and the instructions that we include in here, plus the context. So I think Kroll mentioned earlier, like if you are passing the conversation history, it's going to use some of that to decide as well. In our case, like in this case where we have multiple tools, we're being very specific on how we want those tools to be used. So that we can get closer to having a more accurate output.
So we are going through multiple times through LLM, right? First pass is same search.
Yep.
Okay.
So let me get to the last one that I just did, and I can show you the LLM calls. Any place in the output where it says sending the conversation to Bedrock, that is making or sending the query to Bedrock, that's making it's sending that conversation to the model. So we do that at the beginning. It responds back and says, call a tool. Our agent calls a tool. And then with those tool results, we make a call to Bedrock again. So we sent the query to Bedrock. We respond back with it says call a web search tool. So we are calling that tool here. And then we send those results back in the tool result block. So this is hard to see because this isn't formatted very well. But there's this, as part of this conversation, there's more information that we send along with it. So in this case, part of the conversation includes the results of the tool. And that is what the model uses to decide, am I done answering this question, or can I just start generating an output based on the tool results? So I think it's gone back and forth a couple of times now. This one was using two tools, so it's calling Bedrock again after that second tool use call. And then this is our final output. This is the final response from the model, and this is just the text version of that so that we can see what the output was.
So LLM, the first response, LLM made a decision that that's not the user is asking for. It's on, right? It's LLM's responsibility. It's making the decision that, hey, he's asking something else. Let's go and find another tool, right?
Yes, exactly. Again, it's based off of what we have in our system prompt and the tools available to it.
Okay, got it. Thank you.
Yep. Okay, anything else? I wanna we've only got about 20 minutes left, and I wanna make sure we are getting through a few kind of a few things. Our if so module let me go to the progress here. So we are on this is module 3, notebook 3. The next module, the one called Chatterpine, that is the Chainlit web app that I showed earlier. We're experiencing an issue with it when running it in the platform. So if you would like to see this in action, you'll have access to the code and instructions to do this on your own machine after this workshop is over. I'm gonna actually, I'll go to that one so that we can kind of just see the layout of the code repository. So I'll do that quick. And so in this is the repository that will have the web app in it. It'll be the GitHub repo that we share with you. Will have a handful of folders. You've kind of already seen them already, but one of them is web app, and that's where this is located. There's information in the README on how to get started and how to run it locally. The main thing you'll need to do is set your API key. If you're running it locally, you'll also have to set up your AWS account. If we were able to do this local or in Instruct, that would all be done for you. You wouldn't have to do that, but I don't think this module is working for people. Let's see, what else? We have one last cleanup module that is optional. I just want to talk about it, or I'll go to it. I'm just looking at what all we have here. I want to make sure we have some time for questions too. Let's go here. So in this cleanup module, there's a couple things in here. The first part of it is actual cleanup of resources. Again, this is optional. If you're using since you're in our workshop platform, you have been given an AWS sandbox, so we'll clean that up after the workshop is over. You don't need to worry about that. But since you should be using a starter tier Pinecone account. If you created a new account today, that's where you would be. You don't actually need to go through and delete your index unless you want to. It's good practice to clean up things that you're not using anymore. And so that's why we include this here. You can do it either through the notebook, through this notebook 4, or you can go to the console and do it as well. Actually, one second. Get this back over here. To delete your index, if you're ready to delete it, I'm not ready to delete mine. You can click these 3 buttons if you're doing it through the console and then press delete. But the other stuff that I want to point out here in this section before we kind of get to any more Q&A is these resources. So I'll share this in the chat here in a minute so that you can also access it if you don't happen to grab it here. But there's access to the GitHub repository that we've been working through. That again, it has the workshop instructions. that you see here on the right-hand side. It has the notebooks that we worked through on the left-hand side. It has the Chainlit web application that is running locally in my environment. I don't know why it's not running in Instruct. And then the data that we loaded. So one of the challenges we know that people have is they don't always have a data set to get started with and to start learning with. And so there's some data in there that you can use. We've got some blog posts in here about just kind of some of the stuff we've been talking about today. That last link is a link to some more Jupyter notebooks that we have linked on our website related to retrieval augmented generation and agentic RAG, using potentially different libraries. So not all of them will use Amazon Bedrock. Some will interact with Claude directly through the Anthropic API. Some use LangChain, some use OpenAI directly. So just different examples for you to work through as you're getting going on this. I have one. I'll share these two in chat. But Vamshi, I don't know what else you wanted to chat through here.
Jenna.
Yes.
Someone stated that Notebook 4 is broken. Is that true?
I don't know. I have not experienced that. It might just be in their environment.
It is just deleting the index, right? That's what it's doing. Nothing
Yeah,
else.
that's all that notebook is doing.
Yeah, it's not doing anything.
Yeah. So if you want to delete it, you could go into the console and the Pinecone console and do it. The instructions are in there to do that as well. Otherwise, you can just skip it. I shared two links in the chat. Again, the first one is that GitHub repo of everything we did today, everything we talked about, all the code and the instructions. The second one there is a link to join our Discord community. This is a newer community, and we would love to have you join us there and continue this conversation. I've created a private channel for the people that are in this workshop. If we want to continue the conversation, if you want to get help, if you want to get to know your fellow workshop attendees, you'll be able to do that in there. And if you'd like to be added to that private channel, just send me a DM on Discord and we'll get you added. There's no like special link to get you in that channel. So yeah, I hope we see you over there. We're not going anywhere. Like, we have time for questions. And I see Vamshi's back. Do you have any last things that you want to say before we open up for any more questions?
I have a question.
Sorry, our speaker. Yeah, go ahead. Somebody had a question.
Notebook 3 was not open, so I did refresh the page. Completely, it went back, and I'm trying to give the command for the Jupyter terminal, what we have done in the first for notebook, and the command is not working.
Is it the token generation command?
Yeah, token
Even
generation
for
command.
me, I've been asking since beginning actually, but nobody's helping me. It really pissed off me for me. What kind of things you are doing? I've been asking since last 1 hour.
Maybe there's like miscommunication, because I think we've all been trying to get information here on what is actually happening. Giri, in the chat, can you share a little bit more about what you're experiencing? Because without that information, we're not able to help.
I've already told, man. I've already told. I've been stuck in this API key since beginning for more than 1 hour. I'm not even listening anything. Since API key, you asked me to put enter. I'm putting enter, and it's not even moving further.
Okay, you
said Arjun is going to help me.
I'm trying to help you right now. So, if you wanna, I can look into your sandbox and we can try and debug it together, while Vamshi starts to answer some of these other questions.
Yeah. Meanwhile, so like whoever is struck with the, Jupyter token generation, I'm sharing the code here. Just run it in the terminal there. You will get the token, enter the token in Jupyter, and you'll be able to log in.
Sorry, interrupt. The token is not working, and now the Jupyter notebook page is completely gone. So how to restart this one? That command, Jupyter command, bash command in terminal, that is not found. It's saying that command not found.
Command not found. Okay. So you're unable to see that. Are you able to log in into that Jupyter lab? Rama?
Jupyter Lab again came back to, I refreshed the page because the notebook 3 was not open. And when I refreshed it again, it's showing the beginning, like enter the password or token page.
Yes, but like I shared a command in the chat, right? Like if you run that command in a terminal, it will generate a token. Is that not working?
Give me 1 second. I'll
Yes.
try. I'll
In
try.
the chat.
Yeah. That is also not working.
Okay. Okay. Let me do one thing, Rama, for you. Okay. So okay. Rama, I'm sharing the invite link. Just open up a new one. So it should have you here.
Okay.
Yeah. So this is the instruct link. Just go ahead and open it from a different browser.
Oh, okay.
Yeah. So meanwhile, if anyone has any questions, like please let us know. So let us share you. So Jenna has shared a Discord channel. So you can log into Discord channel. So we are here. So we are here to help you. I know, this has been a live session. So where we are doing a workshop and also like getting it. So few of you might have seen issues because again, there's an external platform we are relying upon. It's called Instruct, like where we are trying to run this workshop. Yeah, go ahead.
Where is that link? I did not see. Is it Jupyter server list?
No, Rama, like in the chat, the Zoom chat, I have messaged you a link.
Oh, okay. Okay. Yeah. Right. Yeah. There, what I have to do again? Continue. Agentic AI. Okay.
Yes.
Okay.
A quick comment.
Yes.
Hey, Vamsi and Jenna, thank you for doing this workshop. Really appreciate it. I know a few people had challenges. That always happens. Once again, a great effort. I have a quick question. How long the workshop will be available after it is over?
So workshop will be available for the entire day today. So if you wanted to go in and run like one more time, like feel free to do it. So you have all the access, and you also have your Pinecone account created, so you can run it entirely.
Oh, okay. I was hoping it's a little bit more than end of the day. Is it possible?
Let me check because as I said, this is an external platform dependency.
Sure.
Like Instruct, I need to check with them. If there is something, like we will let you know.
Okay. Thank you. Thank you both. Appreciate it. Have a good one. Bye.
Maybe couple of days will help us to go and experiment. That's it.
I opened that link in a different page, and now I need to use the command, but whatever the command you provided, the token, that is not working. And here instructions, I'm unable to go back.
Okay, so let me get into your machine. So
Sure.
Okay. Again, so we will, working on this. So we have 3 more minutes. So if you have any questions or anything, do let us know. I know, and we sincerely apologize for the people who went through some hiccups, because we are also learning on running a live workshop and with like larger audience. So we'll make sure we will get better in the next time. But again, in terms of like use cases or anything that you wanted to have an extended discussion, we are available on Discord, or you can, I mean, reach out to us. So let me share my email in the chat. So we'll be excited and happy to work with you. Like shoot us an email. We are happy to discuss about your use cases, about your needs, and help you succeed in building AI applications. So
Very good. Hey, thank you, Jana and Vamsi. This is one of the very well organized workshops that I have been attended. You time management, the instructive training material, that is a very well organized. Thanks, thanks everyone.
Hey, Jenna, is somebody
thanks a
going to
lot,
help me?
Robert.
I've asked to have you share your screen and it was declined, so I don't know how to help you.
When did you ask me? I was here only, right?
What's that?
I was here only. I never been asked to share this.
Okay, through Instruct platform, are you able, like I'm gonna request it again and it should pop up an option to share. Through Zoom, I've also asked for more information on what you're experiencing. Okay, now I can see some stuff. Why don't can you, yeah, okay, so it looks like you've entered the API key. That's what those dots mean. You've already entered it. Can you put your
It's keep on asking me. Again, I'm putting it.
Yep,
and then
put it
enter.
in, press enter.
And then?
No, don't press go again. You need to move your cursor down to the next cell, the next code cell where it says index name. No, the next one. Yep, that one. Now you can press. Yep. So for some reason it's not moving you to the next cell. I'm not sure. It might just be a function of how the Jupyter notebooks work, but it looks like your API key is in there now, and you're able to continue going.
But it says index has not been created. I checked it in the Pinecone.
Where do you, did you go through the first notebook completely?
It says index is missing it, yeah.
Okay. Can we just
Yeah, the
execute
first was
these in
done
order?
successfully, yeah.
Okay, can you share your the Pinecone console, or go to the Pinecone console and let's see. Okay, so you're right, there's no index in here, which means we'd have to go back to that data loading notebook and run through that one in order to create that index.
So when you go back and click here and then start again?
Yep. No, you'll have to open that one. You can just at the top tab there. It's in the editor section on the right. It's already open is what I'm saying.
Oh, okay.
Yeah, right there.
For me, the movie selling was working for me last time.
So you'll paste your key in, press enter, and you'll have to manually move to the next cell. That's good to know. I didn't realize that wasn't moving people down.
It's a Pinecone create index, right? It says say that. It
Yep.
moved it.
So it's still running. The little stars there say it's still running.
Where is it?
The if you scroll up just a
Oh
little
yeah,
bit.
I'm just waiting for this one to
Yep.
stay.
Yep.
This is great right now.
Yep.
So this is available, this Instruct platform available in another couple of minutes. Maybe I can go through and explore myself.
Yeah. So as Vamshi mentioned, it should be available, I think, through at least for another few hours, but I think through the end of the day.
That's fine. I'll explore
Yeah.
myself. Yeah.
And again, like I've shared the links in the main chat. So everybody should have access to the entire workshop content, the instructions, the notebooks,
Okay. Thank
and
you.
everything, and the data.
Yeah.
So yeah, so we have provided our email in the chat. Again, as I said, thanks a lot for your time because 3 hours, like it's a lot of dedication, and we thank you for your time and patience and your eagerness to learn. Yeah, we are here from Pinecone to help you with your use cases. Even it's a brainstorming, please ping us or email us. So we'll be happy to have a chat, conversation, and see you successfully build AI applications. So we are like on top of the hour, like it's 3:03. So we will again, as is like this doesn't end here.
So
We are
in
available in
case,
Discord
sorry
and
to Vamshi, in case you told me last minute, we want to use this. We have been trying to replace it, Mongo Vector with Pinecone.
yeah.
So I'm from eBay, working as a vice president here. So basically, just want to check with you. In case if you want to use Pinecone, we can only use as a vector, right? We cannot using anything other than that.
So when you say vector, right? I mean, in terms of database capabilities, right? So right now, Pinecone offers 3 different capabilities. So vector search, and also when it's a vector search, it's a dense vector search and also sparse search, which is a keyword. I mean, kind of like when you look at a document DB, you upload documents. But if you're looking equivalent to MongoDB, so Assistant is a service like where you can directly upload the documents and search through the documents. Apart from that, we also have integrated inference, so where you can, get for the embeddings. Yes. So Giri, feel free to ping us. So I have given my email ID. So it's
Yeah, sure. I'll ping you.
EAM.
And in case we want some self-hosted, we don't use any cloud platform here, so that's one challenging in Pinecone. So
Yeah, self-hosted is something, that is not offered right now. As I said, like the only closest thing is like being your own cloud. So where, you can have your data plane in your cloud. So apart from that, yes. So it's not available for the self-hosted.
okay. Thank you.
Yes. So thanks a lot, audience. So, again, feel free to reach us. So my email is like vamshi.e@pinecone.io. So yeah, we'll be happy to assist you. And yeah, have a great rest of your day.
Perfect. Thank you so much, Team Pinecone, for joining us and also for giving such an incredible workshop. And thanks everybody for joining in and working along the way with Pinecone. I see there are a lot of questions regarding the recording, so don't worry about that. We'll be sending the recording and they will be with you forever. So don't worry about that, as well as the resources that Pinecone
No, the
has
sooner
used.
if you send it, that is the best. If you send me after 10 days or 5 days, I think whatever we learn, we couldn't able to catch hold of it. That's a
Yeah, we'll
challenging
be
one.
sending you by the end of this week or the start of the next week, like early next week, Monday, Tuesday, right?
Thank
So you'll have everything. Okay.
Bye.
Thanks, everyone. Thank you, Jenna. Thank you,
Thank you,
Vamshi.
everyone. Thank you, Arjun and Corey, for helping out as well.
Thank you so much.
Yeah.
Bye.
All right. Bye.